Good morning, ladies and gentlemen. Welcome to the annual conference of the Clean Energy Transition Partnership. My name is Ludwig Karg. I'm the head of the CETPartnership support team. Today, my support is the moderation of this 3-hour event. We want to inform you, we want to challenge you, and yes, we also want to entertain you a bit. Let me see what we have on the agenda. We can share the agenda quickly. I can show you there are basically 3 big parts. In the first part, we try to describe the challenge that we have selected on sustainability in the supply chain for energies. In the second part, we try to better understand it. And in the third part, in a big panel discussion, we try to rise to the challenge and we try to understand how we can better cooperate with the CETPartnership and many, many other institutions. That was the agenda. And now in my agenda, it says, welcome the coordinator of the CETPartnership. I tried hard to get hold of Michael Hübner, but obviously he is very busy coordinating the next call for proposals, so he apologizes and he has sent his deputy. I'm sorry for that.
Hi, good morning. My name is Michael Hübner. I'm the coordinator of the Clean Energy Transition Partnership. To be precise, this is my comic avatar that you are seeing on your screen right now. He's called Mick. You will see him again in a few minutes, and he will then take you on a little journey into the world of desires and thoughts around the topic of sustainable supply chains in the context of the energy transition. But now, however, to welcome you, I would like to turn to reality. Welcome to the annual conference of the Clean Energy Transition Partnership. With this event, we bring together all the different players and initiatives of this huge network. And we also give the opportunity for many others to learn about our activities and projects. And now, as promised, Mick and me will take you to a little journey about sustainable value chains, materials in the context of the energy transition. As we are talking about the future, a vision maybe, we have decided for this quite unusual format.
It's a challenge. It's our challenge. It's your challenge. The further development of technologies and concepts for the energy transition. Because we need more than what we already know for our clean energy future. An energy future that really offers perspectives for all inhabitants of this globe, our economy today and our grandchildren tomorrow. Yes, it is evident. We need technologies to convert, to store and to transport energy. We need control and smart systems. To provide these technologies, we need materials, knowledge, skilled people and production lines. However, we also need partnership, international collaboration, shared efforts and skills. But what is new about this? It is the new questions that arise from the exponentially growing global market uptake of the new solutions. Where does this all come from? Can we be sure to have all the materials available? Will we get the components and technologies for the growing number of devices in time? Are we able to have our share in the production of technologies and in the value chains of the new evolving markets for new solutions and systems? Things have changed since it all began. So now we have to face up to these changes. A high share of components comes from a very low number of producers. We get more and more dependent on a number of special and highly scarce materials. Not only during the pandemic, we have experienced the meaning of vulnerable supply chains in a globalized world. So why not doing research on how to produce batteries that use dramatically less, or at least less rare materials? Why not considering recycling of components and materials to develop super efficient production lines for a new generation of PV panels, and in that way be at the forefront of producers again? No, of course. These are all not yet answers. These are only questions. Out-of-the-box thinking is required. And it is a tremendous opportunity to do it together with partners around the world. It sounds too complicated somehow? Too impossible? Honestly, that's what people also thought when the first developers considered bringing energy to Earth from the space. Thinking that way means to do research and to develop technology for the future. This is what energy innovation is all about. Working on such kind of solutions is paving the way for the next phase of the energy transition. It is a challenge. It is our challenge. It is your challenge.
Thank you, Mick and Mike, for introducing the challenge and the chances. Now let's try to better understand it. Let me stress again, we are not talking about shortages in gas and oil. It will be more about the materials, the products, how we deal with that, and what we need for the renewable age. We have invited people, 5 people, to give us short introductions. I'm not going to explain in detail. I quickly invite them to come on stage, and the first one is Taeyeon Kim from the International Energy Agency. Taeyeon, you have been involved a lot in the critical material work, and you asked me to not ask you about all these other reports that the IEA frequently publishes. So you can concentrate a bit on the critical material. Later we will see you in the panel. Your stage, Taeyeon.
Thank you, Ludwig. So it is a great pleasure to be here. So critical minerals is rapidly rising up the policy agenda, also business agenda. So, and we believe it can have a major impact on the affordability and speed of the energy transition. So today, based on the report we released in July this year, I will quickly go through what is happening in the market price in terms of critical minerals and also where we are heading. So what we are seeing today is that the clean energy deployment is actually happening much faster than we expected. So in the wake of Russia's invasion to Ukraine, and many expected the clean energy transition momentum might weaken. But what happened is actually the opposite. So clean energy transition is happening much faster. The solar PV deployment in 2022 increased by 35%, and also the electric vehicle sales by 60%. That is just one few examples. So, and in line with that, we are also seeing the burgeoning amount of the announcement to build new plant to manufacture solar panels and batteries. So if we add up this all announced project and they get closer or exceed what is required in our net zero scenario. But on the right side of this picture, in the case of raw materials, copper, lithium, nickel, and the supply is growing in that segment, but the still expected supply falls short of what is required in our net zero scenario. So if you have one part of the value chain moving very fast and the other part of the value chain moving slow, we think the overall pace of transition might be geared toward a slow moving one, which is why we are urging more attention to this part of the value chain to have some balanced development of clean energy supply chains. And what we are seeing actually the rapid growth in demand for critical minerals from lithium to copper and nickel and cobalt. In 2022, over the past 5 years, the demand for these critical minerals for lithium, for example, tripled just in the past 5 years. And the demand for copper, the nickel and cobalt all grows quite extensively. But this is not the end of the story. We believe this is the starting of the new journey in our the transition scenarios. So in our net zero scenario, demand for these critical minerals can grow as much as 4 times by 2030. And this growth is mainly driven by electric vehicles and battery storage, but also there are some major contributions from the low emissions power generation such as solar and wind, and also the hydrogen electrolyzers and also the grid networks. So then next question is about the supply side, whether we can supply and meet this growing demand of critical minerals. So we, in the report, we look at this from 3 supply side challenges. The first challenge is about can future supplies can keep up with rapid demand growth in our climate-driven scenario, whether we can meet absolute level of demand. The second question is about whether those supplies can come from diversified sources. And third, the question is about can those volumes be supplied from clean and responsible sources. So we look at the progress on these 3, the supply side, the challenges. On the first challenge is about absolute level of investment. We are seeing some encouraging signs. The investment in non-ferrous metal production increased by 20% in 2021, and so another 30% increase in 2022. This is mainly led by the lithium and copper, nickel and cobalt, which are mainly the energy transition, the used in energy transitions. And also the same trend has been observed in the exploration spending. The exploration spending increased by 30% in 2021 and another 20% in 2022. This growth is mainly led by the Latin America and Australia and Canada. So it's quite encouraging that we may see some progress on diversification. But if we add this increase in spending will translate into the more supplies in the future. So we think expected supply will increase quite a lot from today's levels, but still that level is not sufficient to meet the net zero scenario requirement. So we still need to go more, and also the education of future supply is far from guaranteed, although we are making some progress on this front. At least in the first side of challenges, at least we are making some progress. But same cannot be said for the diversifications. The level of diversification is still remain very high across all range of minerals from copper to cobalt and rare earth element, especially in the processing side, refining side on the right side, where the China has a very dominant role in all parts of the value chain. And that level of concentration is actually much, much higher than that of oil and natural gas. And why this is an issue? Because as we are seeing some just last week about the announcement to control export of graphite, which is almost entirely dominated by China. And if something physical disruption or trade restrictions or other major event happens in major producer countries, and it can have a major impact on consumers. That is why we are worrying about this high level of concentrations. And what is more worrying is about if you look at the project pipeline, especially for processing, refining, most of the projects being developed in today's incumbent dominant players, which means we are not seeing the much progress on diversification, and we need more effort to accelerate progress on diversification. And finally, about ESG, environmental and social aspect. We look at whether industry is making progress in supplying and clean and responsible sources. In terms of social indicators such as gender balance, the community investment, and health and safety, we are seeing some progress. The indicators are improving, but it cannot be said for the environmental indicators such as greenhouse gas, water use, and waste, where the amount of emissions, water use, waste per ton of output is either remain very stable or worsened. So this is why we are seeing some mixed progress on ESG segment, and the reason for this, but we think there are some scope for improve the environmental and social performance while also developing this range of critical minerals. So finally, addressing these challenges, we think requires some balanced, holistic approach touching upon both supply, investment side, and also technical innovation, behavioral changes, and also recycling segment. We need all kinds of solutions to address these grand challenges. Thank you.
Thank you very much, Taeyeon, for this quick introduction. The rest is in the report, and you will be back when we talk on the panel. The worst thing is that in some cases, other domains, other sectors are even competing with the energy sector. And one sector that might compete is the building sector. So we invited a person from the building sector, Willem Butthus. Willem, you are there. Willem, you are the co-founder of the Better Building Initiative. and you are a CEO, you do a lot of consultancy on corporate ventures, so you know the scene, you know the startups, you know the materials. Give us a quick introduction as to what is the issue with energy and building competing for material or
Thank you
product.
very much, Ludwig. If you can get up my slides, yes, thank you. Competing is one aspect, but there is also a lot of similarities, and we can help each other and learn from each other. I think there are a lot of similarities between the two domains. And as Tayun already explained very well, on the energy sector, we have a lot of concerns about the critical materials. As we see here on the left, also depicted one of the diagrams from his organization. But on the other side, we have the construction sector, and the construction sector is responsible for about 40% of all materials extracted, not just critical materials, but a lot of other materials, which are also becoming scarce, including even sand. It's also responsible for 35% of the waste and 30% of greenhouse gases during the lifetime of the buildings, of which, and actually 15% for the building materials. Now, what is the commonality between those two sectors? That they both need actually buildings. They need poles for the wind turbines. They need waterworks for the hydro plants. They need chemicals and plastics for the wind rotors as well. So both industries need a lot of cement, steel, and chemicals. And those are the most extreme, hard to abate industries we have in the world. So let's talk about them briefly on the next two slides. Uh, the challenges that we see, especially in the building sector, but a lot of it is very similar for other sectors, is that the focus has been very much on CO2 only and on the use phase, and not taking a holistic approach to, on one hand, sustainability, on the other hand, resilience that we need more and more, specifically here in Europe. So we have to understand more where are the materials and the critical materials are coming from, what is the impact of the production and the transport, and especially how can we reduce the amount of material that we need, and how to make sure that we don't talk about waste, but we talk about circularity of the material. The second thing is that supply chains have been a black box for most industries. We know where we buy products and materials, but we don't know the whole deep supply chain, as we call it. Costs have been the dominating factor, and we haven't looked at the sustainability impact or the resilience impact, the risks of the deep supply chain. So we need much better deep supply chain insights, where the materials from come, and that's also essential, as John already explained, to deal with the geopolitical risk, but also interruptions due to floodings and other natural disasters. So we need more insights in the deep supply chain, and we need to do more about risk analysis, early warnings. Thirdly, the critical materials and the material and sustainability issues have been an afterthought in designing new products. Whether we talk about new buildings, new windmills, new power plants, new heating systems, people have been thinking about how to make the best products, but they haven't been thinking about where is the material coming from, how sustainable is the material, and how resilient is the supply chain of that material. So on the last slide, we can talk a little bit about what innovations I think we need in those different areas. First of all, on the holistic approach, I think it's important to get to what I call real LCAs, not model-based, but based on real facts for your individual supply chain. So really looking at where is my material coming, how has it been produced, where is it dug out of the earth, and what is the real life cycle impact of that product that I'm using. Because if we don't, we can't benefit the most sustainable supply chain. We will just get the averages. Very important also, especially in the building sector, environmental product declarations, material or building passports, which are just starting to come along. Of course, we need innovative materials and processes and also designs. And last but not least, we need adaptation of the regulations. There are a lot of regulations in the building sector which don't allow us to innovate and to use more sustainable designs. On the second side, on supply chain insights, we need a lot more tools. There are some available in the market, but we need a lot more, and they need to be deployed to understand what is my deep supply chain, where are my products and materials coming from, and how sustainable are they? Also, what are the risks involved in them? And for that, also, we need probably a legal framework and an independent repository, because most companies are not willing to share where they are buying and sourcing the materials. And last but not least, the design for sustainability and design for resilience have to become standard processes. That means we have to educate managers of companies, of organizations about those topics. We have to educate the engineers and the developers and their purchasing people on how to do this. And to do that, we need to provide them with information on which they can make the decisions. So databases and probably AI-based tools to recommend the most sustainable materials and processes for a new design. And also, of course, we have to train people already at university, preferably, on how to do design for disassembly, design for reuse, and design for recycle. And last but not least, we need more risk-taking investors and project developers, both in the public and private space, because if the demand is not there and the people are not willing to pay for this initially, then it will not happen. That's it from my side. Back to Ludwig.
Thank you, Willem. You said it. We need more insight, and you give me the impression that the building people know how to get into this black box. Do you feel that the energy people are any better, or are they lacking behind?
I think the people in the building sector have it relatively easy because the supply chains are not that complicated. But I come from the electronics industry, from the semiconductors and automotive industry, and there is very difficult. And that is, I think, what we face in most of the energy sector. If you talk about electronics and battery technologies, the supply chains is extremely long and therefore very difficult to analyze. To give you one example, somebody realized that, analyzed that the components that go into your mobile phone, before you get your mobile phone in your hand, the components and the materials travel to the moon and back to Earth.
Oh,
That
thank you.
distance.
Shut up, please shut up. Yeah, it's getting worse. Thank you, Willem. We come to the next little intervention from Marco Morelli. Marco Morelli knows also about long traveling things. They call it grids, power grids. He is a person from Prismian Group, and they deal a lot with the grids. And he sent me a quote that I liked so much. He said, and he quotes Socrates, "The secret of change is to focus all your energy not on fighting the old, but on building the new." What will be new in terms of grids, and can we afford it? Can we get the right material for it? Marco.
Good morning, good day, everybody. I'm going to talk about how the energy transmission can impact on the energy transition. And let me start with a few words, not charts, because you can find them in data from many agencies. But this is to say that the energy market is growing as a whole. And it's true that hydrogen is gradually taking some space, and this is mostly replacing the space that is now taken by oil and gas transmission. But the transmission energy will happen mostly with the transmission of electrical energy. So this sector is growing. It's growing very much. And we believe that the market of interconnectors, so connection between countries, and the connection to renewable energy sources, especially located offshore. The offshore wind is a bright example, is somehow leading a growth of 3 to 5 times of the submarine cable market in the next 5 to 10 years. To do so, the industry is investing. As the whole supply chain, we are investing in capacity for manufacturing and capacity for installing. To do so, we need to count on long-term plans. We need to count on clear regulations. This will support the decision-making process of the decision makers within the industry. The other thing that we are looking at is innovation. Innovation is the core of the energy transmission evolution. Innovation enables so far to go to larger voltages, up to 525 kV DC. If you look at the examples in Europe, going to deeper depths in the Mediterranean Sea, we have examples of interconnectors that are going down to 3,000 meter water depth, going to dynamic cables that are used to connect floating offshore wind farms that are coming now and will most likely last long for the future. And also to go to materials that are fully recyclable. And we now have fully recyclable cables, both in their metallic and plastic parts. All these innovations are accelerating the transition to a better world, the energy transition. What regulators could do to help this innovation is to support financially. This is already done, but also to give more value to patents and to help protecting patents, because this will reinforce the wish and the commitment of industry to invest, to innovate, to get competitive advantages from innovation. The other thing that I want to touch is the importance of sustainability for the supply chain. It's not that sustainability is the target, the final target only. It's also embedded in the process, in the continuous developments of the supply chain. For cable makers, there is one thing that I would like to take as an example of what we are doing positively to overcome the use of a material that is considered to be dangerous, is lead. Lead is considered to be material to be avoided for the future, but for submarine cables we can't avoid this use, and we are investigating what to do. But the industry is not ready. It's not ready yet to change and to take the risk of have a less reliable system that will not sustain the energy transition for a long time. To go a bit into details, in Europe there is the European Chemical Agency that started 5 years ago a process to abandon basically lead, but authorize the use of lead in certain circumstances. And this is one of the cases, submarine cables, where we need to act. We need to have this authorization to go ahead. And there are studies made that were already shared to somehow support this position. First, we see that lead is an internal element that is not diffusing to the sea, to the environment. And second, alternatives are really considered not to be available for reliable application in the next future. So both ENTSO-E and Europa Cable are recommending to still use internal lead until alternatives are really existing. This is important. We are talking in Europe about almost 50,000 kilometers of submarine cables to be deployed in the coming 10 years to allow the energy transition. We are working in the same direction. We are working to have a more sustainable world, but we need to have a dialogue on what is possible, what is feasible, what is the right choice to get to the final target. Thank you very much, and I give credit for this presentation also to Europa Cable, to ENTSO-E, and to Carl-Erik Hillesund that support me for the preparation. Thank you.
Cool. It's a pity that you are not there. We had to pre-record that. Otherwise, I would have asked you how you feel like, would we have enough copper to build all these cables? And if I look at the latest IEA report, they talk about 80 million kilometers of grids that will have to be built by 2040. Where should the copper come from? I will ask Keon in the panel. First, let's go ahead with Michael Braungart. Professor Braungart is the founder of the cradle-to-cradle principle. He doesn't like to talk about recycling. He wants cradle-to-cradle. We also had to pre-record him. Listen to Michael.
Hello. I'm sorry that I cannot be with you in real time, because I really think what you're doing makes so much sense and it's so important. Traditionally, people believe they are protecting the environment if they minimize damage, reduce your water consumption, your energy bill, but you're not protecting, only minimizing damage. It would be the same if I would say I'm slapping my child only 5 times instead of 10 times. I'm not protecting, I'm only minimizing damage. We need to learn to become native to this planet, not to minimize our footprint only, but really to have a beneficial footprint, which becomes a wetland. In this context, we see that we don't have an energy problem, we have a material management problem. to put carbon dioxide in the atmosphere is just stupid, because there's only 2.8% of the Earth's crust is carbon. How can we be so stupid to put it in the atmosphere? We need to have a different goal. We need to get carbon out of the atmosphere. We need to make sure that we have the same carbon dioxide concentration in the atmosphere than we had in 1900, in 2100. That means we need to learn to be good for this planet. And this is not just carbon capturing, it's more about carbon management. If we can get 0.5% of carbon back into soil a year, we can overcompensate all our carbon dioxide emissions. But what we are doing, we are mostly optimizing wrong things and make the wrong things perfect, then they are perfectly wrong. So we first need to say what is the right thing. And in this specific context for energy, it means, why do we sell solar panels when nobody needs a solar panel? We need mostly new business models. We need to learn how to sell what people actually want. They need electrons. They need to harvest photons. And this is why we need to say, how can we really make sure that we can keep materials in closed-loop systems? Because we have more than enough solar input on this planet, but we don't have enough meteorites coming in. So we need to handle things differently. In a certain way, Donald Trump is a more honest liar than we are. There's not one window ever recycled into a window glass. There was never any type of car made into a car. We have 46 46 different alloys in a Mercedes-Benz, and what we make cheap concrete reinforcement steel out of it. With that, we lose all these rare elements like vanadium, chromium, manganese, molybdenum, copper, so on. We call this recycling. Oh, Donald Trump is so much more honest liar, because we don't do recycling, we only make downcycling. Out of a mobile phone, we get only gold and silver, a few elements, but there are 41 rare elements in it. Yes, there is no recycling of mobile phones. And this is why we need to come up with a different mindset to say, hey, we can be native to this planet. We need to learn how to be good for this planet. This means that the energy side is far more, the material side over a long time is more critical than the energy side. And as well, the energy side is not an energy problem. It's a material mismanagement of carbon.
Michael, thanks for this introduction. You avoided the term cradle to cradle, which you would often use in such speeches. Can you give us an example what cradle to cradle would really mean in the case of energy supply?
So when you make a windmill, a wind turbine, you don't need the copper. You only need the service of using copper. It would make a windmill 60,000 euros cheaper if you don't buy copper. It only buys the service of using copper. If you right now we are making high-tech waste management for Chinese hazardous waste when we buy solar panels, but we don't need solar panels. We need only the service of using these. When we only buy the service, then we can make far better materials. We can use far better materials for recycling. We can design things for disassembly. There's a company, Schuko, they went out of business because they were selling solar panels instead of selling harvesting photons. After 19 years, they still had 93% of the capacity, but they were 30% more expensive at the beginning than Chinese solar panels. Over 20 years, they would have been 40% cheaper per kilowatt hour, but they had to file bankruptcy because the Chinese solar panels lost their capacity in the first 5 years, half of it. We would have the world market-leading companies in Europe if we would have changed the business model.
Michael, we met often, I can say that here, and at one point of time you said you would like to do a great project with me. If we would have the chance, for example, in the Clean Energy Transition Partnership, which we don't, obviously, what type of project would you think we should do together? What is it actually that is missing in the research for the future energy system?
Ludwig, it's, I really appreciate what you're doing, because what we see, we are too slow. Yeah. If we continue like we do, we will, at a certain point, pay so much for repairing damages that we don't have money to really rebuild things and to invent new things. So what I really like with your work is that you're enabling people to make a difference. And there are so many things to do. I really would like to work with you on solar panels where we keep the ownership with the manufacturer, and the manufacturer actually sells only 20 years of harvesting photons. Or I would like to work with you on no longer selling light, but selling light performance. It would save about 40% of costs. We need new business models. That's the most important thing.
Let's do it together, Michael. Thank you.
Good. Let's have fun. And thanks for organizing this conference.
Always funny to talk to Michael. He pointed the direction that we need more meteorites to bring us the non-ferrous material back that we misuse. Maybe we take that into the panel discussion. But first we listen to Dr. Paula Kivima. She is a research professor in climate and society. We are talking society now in the Finnish Environmental Institute. And she sent me a quote. She says, just transitions are complex because they involve value judgments. So we are talking sociology now, Paula.
Thank you, and good morning. I'm moving this presentation now to a more macro level and really talking about the nexus of climate, energy, and security. And as we've seen increasingly, unfortunately, in the last couple of years, the direct impacts of climate change are becoming increasingly more visible. We've seen forest fires, extreme heat, droughts, and flooding in different parts of the world. What is important to acknowledge also that climate change has what is called cascading or indirect effects in Europe, for instance. So the impacts of climate change elsewhere in the world affect European trade, finance, and security systems. And when we've done policy simulations in one project, what we've noticed that there are no easy solutions, and it's quite complex ways of how, because both the climate change itself and the energy transition will cause different types of tensions, conflicts, and perceived injustices. But going to the energy sector, I think climate security and zero carbon energy transitions are connected. The zero carbon energy transitions that are talked about in today, they can contribute to future climate security by mitigating the effects and thinking about how do we adapt energy systems to climate change. So the resilience of the new type of energy systems that we are creating is really important when we look at what kind of future world we're living in. I mentioned the trade and supply chains, so both the energy transitions altered the global trade and supply chains, but also climate change creates new type of obstacles to how different resources flow from one country to another. And they both also create combined pressure on land use. So what I've been looking at is what kind of security implications there are from zero carbon energy transitions, and they're quite complex and interlinked, and they can be both positive and negative. But what I've also found interesting in security studies is that we can look at negative security. So we can look at the threats and how do we protect societies and the energy system from the appearance of threats, which we've seen since last year. But there's also a concept called positive security. How can we improve the freedom of insecurity and enable communities to feel more secure? And I think that kind of more decentralized local energy systems and energy services can contribute to this kind of positive security. And these, of course, intertwine with questions of national defense, global security and justice, and local and regional developments. And there it's both important how the new energy niches and solutions expand, but also how the fossil fuel-based energy regimes decline. So some of the security implications that have come up both in the expert interviews, which we've done about 19 for different countries, as well as the academic literature, is firstly the impacts on large-scale transformation to global biobalance and stability, so the geopolitics. And this means, for instance, the reducing power of fossil fuel producers and the uncertainty how they will react, but also perhaps the increasing opportunities for renewable energy producing states. As mentioned in the previous presentations, we're moving from old to new dependencies. So we're looking at the security of supply of critical materials and technological components. It is often seen that decentralization of energy system is likely to lead to smaller disruptions in electricity systems, but there is kind of this intermittency which increases price variation a lot. We are now, with the electrification, we're expanding cross-European grid communities, which is generally, I think you could see as positive collaboration, but it might also create new risks in times of electricity shortages. And renewable energy creates positive impacts on peace building and local communities. However, some of the kind of uncertainties relate to how just are these transitions perceived to be now that we're living in this society where there's a polarization of views and populism, and what are the impacts on global and global stability. And then questions of cybersecurity, for instance. So I think what we need is kind of really to redefine energy security. So when we need to move from stockpiling of fossil fuels to new kind of energy security, what does this mean? And I've kind of, in this thought exercise, I've thought of infrastructure, institutions and agreements, and business models. So for instance, in terms of infrastructure, we need these international grid connections and distributed smart grids. To improve security, we need the developments in electricity storage. And this ties into kind of international energy collaboration and how do we prepare for disturbances. And here it's important to have this kind of tight public-private collaboration to create new business models that improve energy security and address demand response. So finally, just wanted to conclude. So we've seen that climate change and its effects will radically change the operational environment. Energy transition disrupts the existing practices of energy production and use, but creates new solutions for improved security. But there's still a lot of research needed. So we need technical advancements in energy storage, demand response, and energy efficiency. We need tightening public-private collaborations, including social innovations in energy production and use. We increasingly need to look at, on a system level, systemic and transformative thinking and how the energy system intertwines with other societal systems. We need to take into account positive security and how to improve resilience of societies. And for all this, we also need institutional change and experimentation. What type of new policies are needed? And then finally, like the defense forces and military's increasing attention to climate security and new technologies is also important. Thank you.
Thank you, Paula, for this quick run. Enjoy your coffee, stay with us. You will be on stage for the panel discussion later. Thank you. Thanks also to all the other experts who very nicely set the stage for our further discussions. But first, let's dig a bit deeper and let us use examples to understand in which directions we find a solution. It all has sounded like a big problem. Maybe we should look also a bit at the solutions. We have created a little film for you.
Our generation has a great opportunity to transition towards a sustainable and climate-neutral energy system.
Success is not only an aspiration, it is an obligation.
Subject to a complex interplay of factors, stable supply chains for materials and products have taken center stage.
As European countries strive to become more independent,
some sectors, such as the ICT industry, show great progress being made.
It is about time to secure the technology and material supply for the energy transition as well.
And by this, we do not mean gas and oil.
Most of today's renewable energy facilities need rare materials.
What is even more concerning, the increase in demand for critical minerals, essential for clean energy solutions, will reach up to 3.5 times the demand of today by the year 2030.
Mining and transporting such materials often pose significant risks to both workers and the environment. We find frequent involvement of child labor,
and the activities often occur in regions with high water stress.
For most critical minerals, we highly depend on a small number of sources.
This is far from ideal in times of geopolitical uncertainty.
To navigate these waters, it is necessary for governments and industries to closely cooperate and ensure sustainable and stable material supply. But
is that enough? Our scientific history should give us hope.
Shouldn't we also think about alternatives with less material dependencies? With less threats?
And maybe at even lower costs.
Can we imagine a wind power generator without blades?
Without any use of rare materials for rotors, gears or control equipment? Can we imagine a redox flow battery operated with vanilla replacing rare and toxic materials such as vanadium?
Can we imagine a wall insulated with pillows that keep the house nicely warm? Can said pillows be designed with artificial intelligence and use inert, easily available materials?
Shouldn't we think about alternatives for lead as a shield and power cables? Euroable says that otherwise we might not have enough cables to transmit the big masses of electricity from renewables.
Others say we will not have enough covers for cables anyway. Maybe it would be wise to think about systems that need less cables?
Systems that use the power at the places where it is produced.
Or systems that produce the power where it is needed?
Products for the energy transition must respect the climate goals.
Even carbon-free battery storage is in sight, with lithium from geothermal heat.
The energy transition must take advantage of all the available opportunities. It needs partnerships between large and small companies,
Between research and industry,
between politics and the best innovators of our time.
the European Commission emphasizes the need for collaboration in research and innovation programs at both the EU and member state levels,
Partnerships have been initiated for brain health and textiles,
as well for solar photovoltaics and raw materials for the green and digital transition.
The CETPartnership serves as the given partner to address research, development, and innovation for the energy transition.
With its 7 transition initiatives, it co-finances transnational projects.
The knowledge community and impact network ensure that research results will quickly find their way into practice.
As an outstanding research and innovation initiative, the CETPartnership tackles the right questions.
How can we make sure that all the materials we rely on are sustainable?
How can we jointly secure continuous and resilient supply of materials and products?
How can we make the best use of the existing resources?
How can we together build systems that need less of said resources?
Let us be creative.
Let us be innovative.
Let us find the best solutions together.
CETPartnership is the ideal partner for your journey to the future.
So that sounds like there is hope, isn't it? We will dig deeper. We will have experts that explain to us how it can work, what they have experienced. But we know that you out in our audience, you are also experts, and that's why we want you to have a voice. We want to involve you, and for that purpose, I call my colleague Katharina Reffel. She will introduce our polling system. Welcome,
Yes,
Katharina.
hi. Thank you for the nice introduction. So hello from my side. So we have 3 options how you can get to Slido and to be part of our discussions. So the first option would be that you join via the link. It will be also provided in the chat. You can also go to slido.com and enter this code, which you can see here on the slide. Or if you have a QR code scanner, just scan the code and you will be directed to our first question, which will come up later on.
So you please note down how you get there. Could you start the first question right away?
Sure, we can try.
Let's try it.
So our first question is more to see if you get familiar with Slido. So the first question would be, would you prefer to see vanilla in ice cream, redox flow batteries, or in both? So we see people are starting.
We let them go. We let them go and vote and listen to the person who has a clear understanding where he wants to see vanilla. Let's get Dr. Stefan Spirk on stage. Stefan, you are in vanilla.
Hey,
right?
I'm here. Yeah, exactly. Can we start? Yeah, thank you so much, Ludwig, and for the nice introduction question. And I guess my answer is quite clear. So we have been working now on this topic for a couple of years. So I think the first experiments have been done at university like 8 years ago. And now, since 2 years, we are also having a company called Ecolite. And the topic really is, and it sounds a bit like a funny item and a joke, to really use vanillin in an energy storage system. So the company is called Ecolite. If you are interested in it, you also can follow us on LinkedIn, or you can see the webpage, which is now under reconstruction. And we're not doing this challenge alone. So we have a lot of partners. You see just the list here. So it's a lot of universities, a lot of other companies, big and small ones, and some networks. As you know, and we have been seeing this, is that we have this huge challenge in terms of sustainable electricity. We saw it in the previous talk, but we also saw it in the very first talk, that it's not only like the grid that is a problem, it's also the source of the energy. And I think what we should not forget about is also that we have also a problem with the materials, particularly for stationary energy storage. We need to really think about how can we really have a backup storage that is like sustainable. And I mean, we have a couple of options to have sustainable storage technologies when we're thinking about hydro power plants. So there in Europe, unfortunately, most of the places have been already occupied, and the new plants take forever to build. Like a 20 years perspective is not very unusual. Also here in Austria, there was just an example that after 15 years of like an environmental examination, they just killed the project. So I think this is also the reality. And what we're doing nowadays is basically we have backup plants based on coal, on nuclear power, and also like of gas. And I think for the future, we really need to think about all the options, as we heard also of the previous talk. So basically, what we are working on is a flow battery. So the main difference of this flow battery to a normal battery is that you are like separating the energy storage and the actual electrochemical cell. So you're storing it in a solution basically, and you pump then these materials through the cell, and this makes it a little bit less, how to say, prone to degradation. So you have a longer lifetime, and you have some other advantages. The disadvantage is that you need a lot of space, so you can only use it in stationary applications. And the real disadvantage is that the main current technology uses vanadium, which is a critical raw material. And this vanadium we want to replace in our battery. You see here like our 5 kV testing objective here that we have been built, and we have plans for bigger ones. So what is the philosophy that we have? This is very much in agreement with what we heard, right? We need to stop digging holes into the world, like transport materials from a few places worldwide to Europe, creating a lot of CO2 just with transportation, not only with the like mining of the thing, and really need to think about, can we use renewable materials? And this will add, apart from the probably sustainable effect and resilience effect, also strategic advantage, because we can reduce dependencies on politically unstable regions. And what are we doing basically is and what we're working was that we're using a material or materials from waste streams in large industry that we have in Europe still, like lignin is one of those materials, and really use the vanillin you can obtain from there. Yeah, it's really true. So there is a process to make vanillin from lignin, and then to do further chemistry that doesn't use harmful chemicals to the environment to make really electrochemically active materials for stationary energy storage materials. So this is basically one of our assets that we're really trying here to use the regional materials to really convert that, and also to really use the advantages of the raw materials that we have. But however, there is a problem. I mean, we have this big project. It's called Vanilla Flow. It's a European project where we use artificial intelligence. But in the end, we need to think about how can we scale up the technologies we are developing. And the situation is like this in Europe. So we have one company, a single company actually, that produces vanillin from lignosulfonate. So that's a special form of lignin. It's a 15,000 tons per year, and this is approximately 20 to 30% of the world production of vanillin. The disadvantage of this process is that it's an old process, that lignosulfonate is a minor lignin source, so compared to another one. And it uses also some catalysts and has very low yield. So it would be much nicer to have a better process, either using biotechnology where we are also like involved. So, however, this at the moment is very expensive. So it's maybe a factor of like 5 to 10 more expensive than the one from the lignosulfonate. Or the other option is to use craft lignin, and this is what we're heavily researching here at Technical University of Graz with some colleagues who are really trying to use these raw materials and to do some very mild treatments that have no harsh chemistry. But there is no commercial supplier of vanillin based on this craft process. When you look in scientific literature, you mostly see that we are dealing here with small scale applications. So we're thinking about grams. So the knowledge is there, but the scale up and process development very often requires large investments of the company. And this leads to this very often used term like valley of death. So we have a good technology, we have good innovations in Europe, but very often those technologies are not really technology ready for the market. So they are, however, on the one hand side, too advanced for basic research and too early to be convincing for industry to make a commitment. For instance, I can just tell you an example. For instance, in the FFG funded project in lignofractor, we are now reaching kind of like the issue where we can produce kilogram scales. But the follow-up project, it will be very difficult. So for various reasons, it's not only the money, it's strategy that is important for the companies that would produce such a thing. And I guess one of the issues here is really that and this may be my call for action here, that we need more programs where we can bridge the gaps from this basic research to really like having the real applications and where we can have investments. I think this is one of my main items to really state here. That does not only like involve our research and our technology development, but I think this is a main structural problem of the European research landscape. So I think we are very good in innovations, we know that, but for instance, the US, they are much better in having like programs to really bring these innovations also to the market. I think there are now new initiatives. We're doing like European Innovation Council and so on, but I think there must be much more efforts also from the national sides to support these European initiatives. Yeah, with
Thank
this,
you.
I would like to thank you, Ludwig. I just want
you.
to highlight a couple of funders and thank you.
Can you stay for a moment? Can we see what people voted? Yeah,
Yeah.
they wanted for both. But Stefan, tell me, would we have enough vanilla lignin to have the ice cream and the redox flow? But seriously, where does it really come at the end? Where do we get the lignin from?
So the lignin comes basically from like a side stream from the paper making process when you extract cellulose fibers from the trees. So you have the lignin, and this is now used like just to heat, like to generate energy in the pulp mill. And our idea is really to take out the lignin, to do this magic chemistry, to make vanillin and the redox active chemistry, and then to bring it back. So this is what we're investigating.
So it's not only about copper cables, it's a lot about chemistry. We heard that.
It's a bit about chemistry and renewable chemistry, I think, using oxygen as a reactive species.
Thank you for the speech, Stefan. We have another person who knows a lot about chemistry. We invite Dr. Felix Marske. He is the CEO of Nanolob, and he will explain what Nanolob is. But he has a nice quote that he sent to me up front. For chemical startups, we need innovation, which enables top research and flexible development on every stage of technological readiness. Sounds a bit like what Stefan said. It's not only basic research, somehow it has to be taken to the field. Felix Maske, explain what you are doing to your chemicals.
Yeah, so thank you very much to be part of this annual CET conference, and I'm really thrilled and happy to be part of it. Yeah, so I'm the CEO of the startup project Nanolob, which is currently located at TU Berlin, and we are producing novel kinds of heat storage units for hot water storage, tanks, construction materials, and photovoltaic applications. They're called shape-stabilized phase change materials. And now I start perhaps a little bit why we need them. Because heat transition in Germany, Wärmewende, all over every newspaper that you see, is now a top challenge and also now available in the public mind, which was completely different when I started 5 years ago. So why we do need new heat storage materials is because we really need to renovate our energy inefficient buildings. We also have to decouple our renewable energy resources by daytime because at night no electricity is produced. And also something that a lot of people are completely forgetting is the space requirement. The problem is, for example, if you have now a heat thermal pump system by Wismar, you need a really, really big hot water storage tank in your cellar. And in apartment buildings, there's not enough space. So we need more efficient heat storage systems. And one way to do this is integration of phase change materials. The problem here is that, or the opportunity here is that the phase change materials can easily save energy, excess energy, by just changing their phase. For example, ice is heated and the PCM as ice is melted and we have liquid water. And in this case, as much energy is saved as when you would heat up your cold water from 1 to 80 degrees Celsius. So a lot of energy can be saved by phase change materials, in short, PCMs. So we have the problem of phase change materials are mostly these 4 points that are written on the slide. For example, you cannot just mix them with gypsum or concrete materials. They easily leak out of them. They also have a high tendency of phase separation effects. In short, this is a limited lifespan and also affects the heat storage capacities of these materials. They are also moderate flammable and have low thermal conductivities. So how to overcome these challenges? For example, by introducing novel synthesis approaches as chemists for the so-called shape-stabilized phase change materials. A shape-stabilized phase change material like ours, non-loop PCM, can easily have easily the same shape after melting. This sounds a little bit like chemistry magic at all, but it's very simple. Because what we have done is we entrapped the liquid phase change material in 3-dimensional nanoporous sponge structure. There, the capillary forces are really high, so no PCM can leak out. So you cannot see anymore in our product if the material inside these pores is melted or frozen. And what we have here is latent heats up to 200 joules per gram, stabilities in the range of gypsum boards of 3 megapascal, and also lifespans and durabilities of over 32 years. And here we are also like the leading startup worldwide with such shape-stabilized phase change materials in our product portfolio. Yeah, here a short slide about the end customer benefit. For example, if we integrate these non-loop PCM or SS PCMs in a hot water storage tank, substitute the water for our product, for example, 20% of it, we lower down the electricity, gas, and oil demand. And if you, for example, mount in your apartment building 2 of our 600-liter non-loop storage tanks, you have an amortization of lower than 8 years, in best case, for electrical heaters, only 3 years. And yeah, you can think about much more applications for these SS PCM or shape-stabilized phase change materials. For example, the automotive industry is really interested in bringing them into action in electrical vehicles, like cool down batteries to overcome the overheating problem. The same for photovoltaic systems. Cooling increases here the efficiency dramatically. But you can also follow the path that we are currently doing by introducing them in thermal hot water storage tanks. For example, you can bring them into walls, these heating wall pads, to enable passive heating and cooling houses in the future, or to bring them also in electrical heaters. So the open question and also like the golden goal for the future of all PCM chemists is creating SS PCMs with very high thermal conductivities, because if you do this, you can easily use them in nearly every battery application. Very nice. Flammability issues should be overcome by incorporation of a broader range of inorganic PCMs. And it would be really cool if you have like 10 SPCM papers for cooling down your next smartphone of Samsung, Apple, or everyone else of these suppliers. So again, thank you for the opportunity. This is my lovely team. We consist of 4 members. Patrick Richter is our CEO. He is on the right side, and in the middle, Eric and Shivai, who are our CSO and CTO, and myself, who is the CEO. So thank you again very much.
Thank you,
I'm open for
Felix.
questions.
And I hope that we will have your lovely team in one of our bright CET partnership projects. You said it. I mean, this morning I told my wife there's a person who tells us how to replace the polystyrol with something better in the balls, and she said, why should we? I then explained it with the melting ice, and she got it to some degree, but still we all are laymen when it comes to chemistry, to be honest. What other people, what other types of research would you join forces with when it comes to getting into this entire energy transition field?
Yeah, that's a very good question. And I would say one company that is one of our key partners is, for example, the bigger company Coda International. They are based in England, and they are the main manufacturer of these phase change materials. So they really like us as key partner to improve their materials and also bring them in application. But also, for example, the Swiss company Soblu, which is mainly a photovoltaic solar thermal panel producer. Yeah, and here our product is perfectly suited.
What would you expect? I mean, you know the CETPartnership. We have funds, and we have people, and we have a knowledge community. We have an impact network. What would you expect from an institution like the CETPartnership?
Yeah, the CETPartnership is for me like a broad community, first of all. Also to bring this green chemistry mindset into action. I mean, we always hear green, green, green and sustainable, but how do we measure it? And for me, it's completely the 12 principles of green chemistry as chemists. And because here we have a good like algorithm, a good rules which we can follow. And the CET is like an interconnection also for funding, because one of the main problems of startups is always the funding. And BASF, for example, needs 10 years for upscaling. We have to completely synthesize a new product and do the upscaling, both of them. That's normally like 15 to 20 years in industry, and we have to do it in 2 to 3 years because the funding period is not higher and longer.
Thank you, Felix. And I promise we didn't pay him for saying that. Thank you, Felix. See you later. Next is geothermal, getting to the earth. We have 2 persons. We have Esther Claridge from Town Rock. She's a geothermal geologist. And we have Doreen Dinkelman from the Netherlands, who is also a geoscientist at the TNO. And both try to make this earth a good storage somehow. Please, the 2 of you, come on board. Please give us short introductions on your work, and then we will have a little bit of time to discuss. I think we said Hester will start, right?
Thank you. Yes, hello, I'm Hester Claridge. Thank you for inviting us along today. I'm a geothermal geologist, and I will be speaking on behalf of the Galleries to Calories project, based in Edinburgh, Scotland. So the Galleries to Calories Heat Geobattery project examines the use of abandoned flooded coal mines to store and transport waste heat. It's an international research consortium, and we have partners in Scotland, Ireland, and the United States. And we also have a number of cooperation partners based in the UK. Now, there are 3 main research questions from this project. These are initially to examine the feasibility of using mine water energy to cool a large data center and store the heat in the mine workings beneath the site. So we'll be looking at examining what waste heat is available, where we can place injection and abstraction wells, determining whether this is techno-economically feasible, and also outlining the environmental and social risks, which form part of a much bigger project risk assessment and risk register. We will also be developing an experimental field site. So we'll be conducting baseline monitoring both local to the site and further downstream. We'll be drilling abstraction, injection and monitoring wells, and also conducting hydraulic and tracer testing within the boreholes. Using this data, we'll be examining how we can actually make heat geobattery projects happen. So this includes modelling the heat storage, transport and the recovery, which I'll discuss a little bit later, as well as examining the financial and heat ownership models of a heat geobattery. So what is mine water energy? For those who are unfamiliar, when you're coal mining, you remove very large corridors of coal, which creates vast spaces beneath the surface. Once the mine is closed down, the pumps are turned off and these mines fill up with water. And this creates large bodies of warm water in networks beneath the surface. The map on the right shows the extent of mine workings across the central belt of Scotland. Now, Scotland also suffers from very large amounts of fuel poverty, with 1/4 of the houses in the central belt facing this. And we also emit a lot of waste heat from industrial processes. In fact, we produce 1,700 gigawatt hours of heating from around 1,000 sites within Scotland. So what this project looks at is storing this waste heat in mine workings and using them as a free heat network for domestic heat users. So we're looking at repurposing fossil fuel infrastructure into renewable energy infrastructure, turning what is currently a liability into an asset. So this is the geobattery concept. We're using mine water to cool a large heat emitter. And for this project, we're using a large data center, which overlies historic mine workings and storing the heat in the mine workings. Then, using the natural mine water flow, this warm water is transported downstream where it will be picked up by local domestic heat users. So the site you can see on the right is just south of Edinburgh, near a place called Roslin. And the geobattery itself covers an area of 5 kilometres squared. You can see the regional kind of ground flow and points that we expect to see interaction with the mine workings. So here are some initial modelling results undertaken during the project. This is by a PhD candidate from the University of Edinburgh called Ale Perez. And this is prior to any of the field testing taking place. So he's modelled the heat plume transportation downstream, modelling where it travels within the mine workings and what's the expected heat energy that would occur beneath the domestic end users. This is an ongoing process and we'll also be modelling how much can be sustainably extracted from the heat geobattery and also inputting data from the field sites when it is up and running. So these are the main outcomes from the GTC project. Ultimately, what we want to do is make more heat geobattery projects happen. To do this, we'll be developing a techno-economic modelling tool for the heat geobattery concept that can be applied to future potential projects alongside a best practice guideline. The project will also be developing policy and regulatory recommendations for both the UK and Scottish government to help aid the development of heat geobatteries. We will also be setting out guidance for the application of heat geobatteries to metal mines in both Europe and the United States. And we will be producing supporting materials for local authorities to help them understand, permit and support heat geobattery projects, especially how they can interface with local heating networks. We have currently entered the second year of the project and we'll be deploying our experimental field site at the start of 2024. So it's a really, really exciting time for this project. We look forward to kind of seeing how it develops. So thank you very much.
Thank you for this first input. You stay, please. So we get an impression that we can store a lot of heat. When I talked to Doreen, our next speaker for the first time, I asked her to give a presentation on heat store for electricity because people claim that how shall we store the electricity? Everybody has an idea how to store the heat. You can store it in big masses, but Doreen, you will not really dig into the heat store for electricity, but you can give us a clue that we can store even more heat. And then we discuss the thing with electricity.
Yes. Yes, Thank you, Ludwig. That's true. I'm Doreen. I'm from TNO. That's a Dutch research organization for applied research. And yeah, I will tell about underground thermal energy storage. So that also involves mine thermal energy storage, where Hester talked about, but also other types, and how this underground thermal energy storage really helps for the diversification and resilience of the European energy system. So here are the different types of underground thermal energy storage. You use the subsurface to store energy, for example, in water, like sand layers with water pores in there. So you can use the aquifer, it's called an aquifer, to store energy. You can store it in boreholes. So it really depends on the geology, what type is best for the specific location. Or you can use it, store it in man-made structures like mines or caverns. And it can typically store water volumes from 1,000 to 1 million cubes of water, so very large volumes. And this results in very large storage capacities of about, well, maximum 90 gigawatt hours. So due to these large storage volumes, you can store over seasonal timescales. So here you see the heat demand for a typical Northern Europe country. So it's very high in winter and low in summer. And if you have then a base load heat source, for example, geothermal energy or a waste incineration plant, you can store the excess heat in summer and use it in winter. So really the seasonal time scale. And the same accounts for the electricity. So you can do this power to heat, it's called. So if you have high electricity production in summer, for example, from solar PV, you can turn it into heat by a heat pump or electric boilers, and then store it and use this in winter when you need the heat. So this is this power to heat, this electricity component that Ludwig also talked about. And I also want to point out, it's not very known technology yet for storage. So there's actually very large potential in Europe. This is a study that combines the heating demand, the excess heat, and the subsurface suitability together. And it actually shows that about 690 petajoules of excess heat is within 5 kilometers of a district heating network above one of these aquifers or mines. And that's already in about 400 locations in Europe. And then this is only 2 of the technologies, and there are way more. So there's a huge potential for this storage technology. And it really complements the other storage technologies. I really like this image. It shows the time scale and also the capacities. And in blue, you can see the electricity storage systems. And in orange, the storage system for heat. And then you can typically see that electricity storage is up to days or weeks. And this underground thermal energy storage can really store for seasons. And compared to the gas storage system or hydrogen, it's also relatively cheap. Then from 2018 till 2021, there was this heat store project that was initiated to accelerate the development of underground thermal energy storage. And one of the the lessons learned was that demonstration projects are really crucial to further develop this technology. I will give one example, a successful demonstration project in the Netherlands. It's the aquifer thermal energy storage, so storage in sand layers in the subsurface at about 300 to 400 meters depth. And it's actually the largest unknown battery of the Netherlands. It can store eventually up to 20 gigawatt hours of energy. And it's fed in by a geothermal source, and it's supplying to a greenhouse. And it's actually, there's now a very interesting business case with the high gas prices. And also regarding the material supply chain, it's really interesting because you use the subsurface as a storage medium. So yeah, you have very low pressure on the critical material supply chains with this technology. On the left, you see, I think it's mentioned before already, the materials we will need for the energy transition, especially for batteries, a lot of lithium and graphite, etc. And on the right, I pointed out the materials that are needed for thermal energy storage. So that's very diverse from the other storage technologies. You need plastic, insulation materials, and just hot water in the subsurface. The only thing is that we do yeah, you do need a lot of knowledge, so human capital, and so that is a requirement, and that's why these demonstration projects are really crucial to actually exchange the knowledge, and not only in a work package, one work package, but really do these demonstrations project together and learn from each other. And also learn from different configurations and different heat sources and heat sinks. So yeah, so we have this knowledge and we can further develop this technology.
Thank you for these two little speeches. I have to tell the audience a secret. We had a very nice exchange on email on last Sunday, I think it was, where I insisted in this sector coupling discussion. I mean, I understood you can store a lot of heat. I understood that you can turn power into heat and then you can store it for winter. That's fine. But is there a chance that we get electricity out of that heat? So what prevents us from creating something like heat to power?
Yeah, I really like this discussion as well, Ludwig. Because in this heat share project, we really focused on the low temperature heat sources and heat storage. So then I would say there's probably not of technology development needed with this organic Rankine cycle, for example, to turn very low temperatures into steam for electricity. But I think in the subsurface, there are also already projects where you can store temperatures higher than 100 degrees. And then I think it might be interesting to look in these heat to power options.
So
but for myself, I'm not
we,
familiar with it yet.
Maybe we put it in the next call of the CETPartnership. It says then Ludwig loves heat to power. We need to do a project on that. Hester, will you be on board?
Absolutely, yeah. I believe that the market currently, you can make electricity from 80 degrees Celsius, but below that, I think the techno-economic feasibility of it is really, it's not been examined properly yet. So again, more research, more money, more time into developing these technologies is definitely what's needed.
So we see you in the next projects in CETPartnership. Thank you for coming, Hester and Doreen, joining. And we come to our next polling. We have heard a lot now, which direction we could do research. We had some hints on open research topics, and it's not only the topics that Ludwig can envision. Can we do a nice poll, Katharina? The poll is about what are the topics, right?
Right. So basically, what are our open research topics with respect to the presented concepts you just heard? So we see already that we have 3 answers given, but I guess we can take some more time so that more people can react. Or what do you think, Ludwig?
So we create a little pause here. And I follow what's coming. I see what people type, right? On the screen. So we have security issues. Right. Network materials. Batteries. The extra word, long-term usability. You know why we are doing that? Every year in CETPartnership, we sit together and say, what could we call for? Now you tell us. Role of seasonal storage, but also to store electricity for me. Social, societal aspects. Flow batteries seems to be a technology. So it's not only trying to get more of lithium, maybe we should replace the lithium to some degree with vanilla. Cradle to the grave. No, 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 no. Don't call it cradle to the grave. Michael Braungart will kill me. It's cradle to cradle. Okay. Social equality and decentralization. Well, purely mean. Maybe we put you on this track, but it sounds like chemistry is an issue. Circularity.
Ludwig, perhaps we should let the people go on with it and in between show the next session.
That's a good advice from our studio director. Thank you at this point of time to Mr. Spanik, Christian Spanik, who makes this happen. I only tell you some nice stories, but the person behind is Mr. Spanik. So let's see, we can come back to it. Let's see what Bruno Kova wants to tell us. Can you show me his picture?
Let's focus in this.
Here comes Bruno. Bruno Kova is a director of advisory service studies at CESI. Everybody knows what CESI is. It's the Centro Elettrotecnico Sperimentale Italiano. And Bruno is there since, I must lie, 30 years, 35 years. He's one of the best experts on really systemic approaches. And he sent me this sentence: we must be honest, realistic, and pragmatic. Unfortunately, I cannot ask him questions directly, but he pre-recorded a very, very nice speech for us.
Let's focus in this contribution on the urgency and the role of research and innovation. You all know that the European Union has been a forerunner in the decarbonization process and has recently reviewed upward the intermediate decarbonization objective to be reached by 2030 with the two packages, Fit for 55 and Renewable Power EU issued in May 2022. But we have to be honest, realistic, and pragmatic. The European economy is still largely based on fossil fuels. The largest share of them are imported, and you can see here some impressive figures on how much is the volume of imported energy. This has, on the one side, an impact on the society. You can see these amazing figures on the European energy bill paid last year, with a focus also on Italy, and makes it Europe vulnerable to external shocks, as happened in the post-pandemic recovery, with commodity prices skyrocketing, and last year with the Eastern European crisis. So, when moving forward to renewable energy, okay, this makes Europe stronger. We don't have to import wind and solar that are available on the territory, but we have to focus first on the infrastructural effort, building more lines to convey green energy from production to consumption center. You can see here some impressive figures of the last TYNDP 2022 issued by ENTSO-E. And consequently, a monetary investment effort. You can see here the focus on Italy. In 15 years, the effort has went up by 5 times, from 4 billion to more than 21 billion in the 10-year National Development Plan. So on the one side, we have to focus on new innovative solution, basically the concept of hypergrid. Here is one example, one practical example launched by this year by the Italian TSO. which envision a DC grid overlapped, superimposed to the existing AC grid, exploiting the key advances in DC, basically multi-terminal configuration, modern DC grid operation emulating the AC line, exploiting the performances of DC breakers that CESI is testing in its laboratories, notably in the Netherlands, consider the interoperability of different systems from different manufacturers for protection and control. Standard and testing are key to ensure good performances. Then there is the other part that is related to the conversion of green energy into electricity. You can see here 3 examples related to solar, wind, and also storage that is needed to stabilize the system. Europe here is again showing vulnerabilities because all the supply chain from raw material to assemblies are basically relying on external players. You can see here the situation now of the green technology supply chain from raw material to process materials, components and assemblies. Almost everything comes from outside, and some of these materials, even worse, are imported from one single supplier. Magnesium from China, borate from Turkey, not to speak about rare earth. You all know that European Commission is aware of this. They issued the Critical Raw Material Act in March this year. But my question is this act and the objectives are realistic? I said at the beginning we should be pragmatic, realistic and honest. How can we move from 3% of domestic extraction to 10% in only 7 years, less than 7 years? It takes at least 2 years to reactivate the decommissioned mine, or more than 10 years to start new mining activities based on the best available technologies. All that said, we must push this objective of having a green Europe not vulnerable from exposed to external players. I highlighted here, just to conclude my presentation, just 3 measures: recycling, new greener technology, and sustainable technologies. Recycling, because, Europe did a good job for recycled materials used in the 20th century, steel, aluminium, tungsten. We must do the same for materials used in the green technologies. It's not easy, but we have to address this aspect. New greener technology. Now, to get these materials, we are now impacting on the emissions. For instance, 15 tons of CO2 emissions to produce 1 ton of lithium from hard rock mining. If we produce lithium from geothermal steam, like in the Rhine Valley, that is already a reality, we don't have any CO2 emission. This is an example of how we can move to a greener technology for getting this raw material. And then we have to consider the footprint of all these technologies, adopting some solution that might be sometimes trivial, but less impacting. So we might have poles in timber poles installed instead of steel poles. It reveals less impacting on the environment with a better carbon footprint. These are just in a nutshell, 3 messages and on what we have to address to pursue the decarbonization process and progress in the towards clean energy.
Yes, thank you. So we heard it. We should not just look at this single technology. We have to build systems of systems. We must link the domains. We have to combine local with global. And I think I understood a bit. We build timber poles, and at the end we turn them into vanilla to run the redox flow battery or something. Joking. Let's see what comes next. We would like to do a polling first, my dear friend Christian. And I call Katharina for a last time. You have been listening to all these ideas, advices, and the question would be now, what would you feel are the best topics that we should look in, right? Katharina?
Yes, so also always in relation to our main topic, resilience in the supply chain. So the poll is open now, and yeah, we kindly ask you to bring in your ideas. We've heard different concepts, such as replacing critical materials with vanilla flow. Then I'm sorry, I cannot see it because there's something in the front.
Oh, somehow we are breaking here. So let it go. Let it go. We see the results later if it doesn't work now. Was there hope, Katharina?
One second, please. I need to restart. So yeah, so here you have these 5 different concepts: reusing existing infrastructure, galleries to calories, connected domains on heat stored for electricity. Then we had the topic on vanillin, replacing critical materials by vanilla flow, optimizing the use of existing materials with heat pads for the walls. And the last topic on systems of systems, systematics systems. So sorry, it's changing all the time. But yeah, I see we have some participants answering the poll. So it's changing in between. So we do not have a definite result yet, but I guess we can keep it open for some seconds.
We keep it open.
And
We will
also
present it
later on
later.
we will,
When
yeah,
we are in
and
the panel, we will present it to the panel and we will discuss it.
Okay.
Thank
And
you very
anyways,
much. Also,
the results will be also in the slides, which we will provide later on the website.
Thank you very much. Thank you very much, Katharina. I think you have to go. You have other duties now while we do the panel. We have heard a lot. There is a challenge, and there are quite some ideas to manage the energy transition. We have to dig a bit deeper in what we have heard, and especially we want to see and hear what could be the role of the Clean Energy Transition Partnership in that game. We called the panel session Rising to the Challenge, Cooperating in Europe and Beyond, because we feel that there are so many institutions, there are so many approaches, there are so many wise people that we need to talk to when we want to get to a real solution. If we want to avoid using critical material or rare material, there is no meteorite that will bring us new metals. You, as the experts in the audience, can influence our discuss through a chat. You can give us some questions while we will be on stage with these 7 people. And we will have another poll for you, so stay with us. We will involve you. Now let me see if all my panelists made it to the studio. Let me introduce them quickly, and then they should be all on stage and we can start discussing. First, I would call again Paula Kivima, who has spoken already. And you know, she is from the Finnish Environmental Institute. And you said it, you are currently researching the interconnections between zero carbon energy transition and security. And you also said when we met, let's talk about social, societal, political RDI, in addition to technological RDI. That's gonna be interesting. I call upon Philippe Jacques. He is the managing director of EMIRI. Everybody knows EMIRI, the Energy Material Industrial Research Initiative. He is a strong believer in open innovation and in the power of European partnerships, he said. And he says, President von der Leyen's priority for 2024 on advanced material for industrial leadership is very welcome. You will explain, Philipp. Next is Jochen Kreusel. Jochen Kreusel is the president of TNT Europe. Who does not know it? It's the Association of the European Electricity Transmission and Distribution Technology Providers. And he's also global head of an international company. I don't know if I can mention it. You will mention it. And also he is still, I would say, a honorary professor at the RWTH Aachen. So you are living 5 lives, I think, Jochen. You will tell us how you manage. And Jochen said at some point, the transformation of power systems has reached a phase in which the entire system across all stakeholders needs to be understood and shaped, the entire system. Partnering is key to achieve this. Thanks for coming, Jochen. Next, we have Dr. Luigi Crema. I met Luigi at the Fondazione Bruno Kessler in the Trentino just recently, and we had a nice discussion how you at the FBK, how you approach it, how you collaborate in research and innovation with small and big companies. And I'm happy to announce that Luigi Crema has also been appointed the president of the Hydrogen Europe Research. So we have 2 persons in one. Thanks for coming, Luigi. Then we have again Taeyeon, and I hope he made it back. Thanks for coming back to us. As we said before, the IEA issues one important report after the other, and you said it. Don't ask me about all these reports, but you know a lot, of course, and you have a good overview. But we will talk mostly about material because you are the one who knows that a lot. And last not least, I do invite, and I'm hoping to see your face, Rosalinde Vander, please. Yes, welcome, Rosalinde. Rosalinde is the Director for Clean Planet and the Directorate General Research and Innovation. And I admire what you have put on your LinkedIn profile. I'm a mother of 3 Dutch by birth, but European by heart. How could you say it better? Thanks for coming, Rosalinde. And we said that everybody can introduce themselves with 99 seconds statements telling us what you have heard. I mean, some of you obviously have followed our little discussion. Christian Spanik, this is not a good sign when you speak up.
I just want to know 2 things. First of all, we have an echo on one place. I don't know where. We have to find out. And second is, can everybody please just in a row first say hello to Ludwig, that we're quite sure we can hear you before you start your 99 seconds. Ludwig, could you say hello, just hello to Ludwig?
Hello to Ludwig.
It works. Felipe, could you please?
Hello everyone.
Great. Paula, your turn.
Hello, everyone.
Great. Rosalind, can I beg you to say hello?
Good morning.
Okay. We have a lag between audio and video, but we can hear you. Jochen, you are.
Hello.
Dion, I'm quite sure it works, but please could you say hello to Ludwig?
Hello.
Great. Thanks all for the short hello. Now, Ludwig, it's your turn again, and I'm off.
Okay, so we tried with the 99 seconds. So what have you heard? What can you comment? Do you have an issue with something that has been said before? What do you want to tell us up front? And I give the honor to Rosalinde first.
Yes, thank you very much. And it's a real honor and pleasure for me to be here with you today at the annual conference of the Clean Energy Transition Partnership. And I think what I heard today is that we have many challenges ahead of us, obviously, to make the clean energy transition a success for Europe. But I'm also very confident that by working together, we will be able to address the challenges ahead of us. And I'm very much looking forward to this panel discussion in particular, to dive a bit deeper into the challenges, but also into the solutions. Because I do believe that, as Europeans, collaboration across national borders is really in our DNA. And if we use all the positive energy that we have in the European Union, I'm sure that we can make the energy transition for Europe a big success. Thank you.
And for the climate. Thank you, Rosalinde. I define the role and the series. Please, Paula, go next. Ladies first, I was told.
Okay, thank you. And I just wanted to say that I think the sustainable supply chains of the energy sector is an important topic, but not an easy one, because there are also different dimensions to sustainability or change, but also I think increasingly in the natural environment and biodiversity laws too, as well as social sustainability. And I think some of the choices we are making today, for instance, related to critical materials, involve difficult questions of environmental protection and social justice. I think a good example is this sort of problematic of whether to increase or how much to increase production of critical materials in Europe, where many areas are located in the cultural environment of the indigenous Sami people and valuable nature, or how much we continue importing from the global south, where mining is at least partly conducted in places using illegal child labor, bad conditions for women, and environmental destruction. So in that sense, there are no easy solutions, but I think there's a lot of innovation, which we saw in the previous presentations, that decrease pressure on resource use, application of energy efficiency, and I really like seeing the kind of presentations dealing with cradle to cradle and energy use.
Thank you. So materials. So I call Philip, I think it's materials.
Thank you, Ludwig. Yes, so thanks again for also having me with you and giving me the opportunity to also share my thoughts on this very important topic of and all the challenges we are facing on energy transition. And no surprise from Emery's side, we are very much focused on materials, especially on advanced materials. We are really advocating for more aligned efforts really on the development of really sustainable and better materials that will really be enabling and that will really facilitate really the achievement of the goals of the Green Deal, and that will contribute to this energy transition. So I'm not totally naive, and I know that it's not only about the question of technology. There are, like other mentioned, a lot of other challenges that we need to consider about the way of life, our habits, our behaviors, and really changing also, and there are some societal aspects that need, of course, to be considered. But technology can help, definitively will help, and advanced materials are definitively part of the solution. So happy to be there.
Yes, thank you for coming, Philip. Next on my list is Jochen. Jochen, which hat are you wearing today?
Good question. First of all, I have to apologize that I couldn't follow the previous speeches, so I cannot talk about what I've heard. Then a minor, let me add a little bit more precision to the introduction. So I'm not the global head of Hitachi Energy. I'm global head of a function within Hitachi Energy, primarily dealing with the energy transition, and that leads to the answer of to head. I'm not sure that whether the differences between the different heads are that big. because my function is about interacting with, let me call it the ecosystem, because I believe that, and you quoted me during the introduction, that we now have the full picture in order to make this transition a success, that we need to think through things to the end, long forward looking, in order to make the right decisions now. It's not about adding or optimizing only a small part of the system anymore, or a part, maybe it's not a small, like in the early days of the transition, when it was enough to focus on installing renewable generation capacity, things like that, and the system did the rest. In the period ahead of us, or maybe even in the period we are in already, the system will not automatically do the right things. We have to transform the system, not only parts of it.
Thank you. Oh, everybody stays in the 99 seconds. That's very nice. Next one on my list is Theon.
Hello, it's great pleasure to be here and rejoin this panel discussion again. Thanks, Ludwig. So I'm Tae-Yoon Kim from the International Energy Agency. So I'm lead IAS work program and analysis and modeling on critical minerals. And although I'm mainly in charge of this critical mineral analysis, but also our team produced a lot of other reports, including the grid report you mentioned, and also the World Energy Outlook publication, which was released today, and also the updated natural wave. So I will touch upon those reports to the extent possible in the panel discussion. And the message I like to highlight is about the need for some balanced and holistic approach when it comes to the issue of critical minerals. And often the people tend to focus on more supply, more production, more investment. Those are absolutely necessary and it's essential, but also we need to unlock the power of technology innovation, behavioral changes, and recycling to address these grand challenges about critical minerals. So I'd like to touch upon this, the need for this holistic approach in my panel discussion going forward. Thank you.
So now you live in danger. I will ask you so many questions to the other domains. So last not least, Luigi Crema from the Fondazione.
Thank you. Thank you for the kind invitation. It's really a pleasure to be here and to support this panel. As Hydrogen Europe Research, we are one of the 3 pillars of the Clean Hydrogen Partnership. So we are supporting together with the European Commission and Hydrogen Europe representing industries, the development, research, innovation of hydrogen technologies and their initial deployment in hydrogen valleys. But apart from our specific role to create this value for hydrogen in the decarbonization, I think all of us have one transition and one final goal. And so to reach out this, we should join our forces apart from a silos approach. So we want to develop in Europe a sustainable energy system, and sustainability is linked to the conversion of resources at the same rate at which they are naturally replenished. So looking to renewables mostly. Without externalities, so zero externalities or minimal externalities include even higher quality as well. And of course, using directly the more that we can of the available resources directly, but at the same time, even creating from our point of view, a stable, redundant, secure of supply energy system, and even together optimizing the total cost of investment of the whole transition. So this is indeed a big challenge with the need to look to the full picture at the same time.
That will be important, I guess, yes. So people, the rule of the game is I ask a question and I assign this question to one first person. If someone wants to get in, has different opinion, you show your hands or you start dancing, I will watch you and we get into a discussion, okay? If no one dances, I will ask a person. So that's the game. I will ask first Rosalinde. And I would like to discuss a bit about what do we know and what we not know. We have heard, and most of you have heard some of the experts and their insights, and some did directly point to issues we need to consider, and some said we don't know enough, and some said, okay, we know, but we don't bring it to the field. But what is it in your understanding? What are the really limiting factors of the energy transition? What is it that we don't know or have? I know you have an opinion on that, Rosalinde.
Yes, absolutely. Thank you so much for this question. I mean, I think to start with, it's very important to underline that we actually in Europe already know quite a lot. And I think that we on many fronts are really front runners in terms of scientific knowledge generation. And somebody called Europe some time ago a scientific powerhouse, which I believe we are and we can be proud of. I think it's also very important that as Europe, we need to learn how to transform, our scientific powerhouse also into commercial successes. And I think here we still have a lot of challenges ahead. But zooming in on accelerating the clean energy transition, I would like to highlight 4 specific challenges. The first one is linked to the grid and the grid integration. So integrating renewable energy into the electricity grid, it can be very complex, since also the grid was traditionally designed to centralize power generation from fossil fuels and nuclear sources. So this is why through Horizon Europe, our framework program for research and innovation, we are looking into the grid integration challenges, also challenges and opportunities, I should say, linked to the digitalization of the energy systems, and also to ensure that the grid manages the demand response side of the energy provided through the grids. So this is the first challenge that I would highlight here. The second challenge for me is still linked to the storage of energy and the need to look for alternative energy storage solutions. We are working, for example, on advanced battery systems, which are essential to manage the variability of renewable energy sources. And we believe that the energy storage technologies is another challenge, a second challenge that we are focusing on through our program. The third challenge that I want to mention is linked to what many speakers already mentioned before, the materials issue, where it would be extremely important for the European Union not only to reduce our critical material dependency, so looking for alternative solutions there, but also to continue to build our circular economy. So really to look into solutions for recycling of materials, reusing of materials. And here again, this is a big priority under our European Framework Program for Research and Innovation. And then if I may, Ludwig, a last challenge that I would like to mention, and again, it's also something that has come up again, but I would group the last challenge as, all the challenges related to ensuring that the energy transition is human-centric. So this means that the energy transition needs to be affordable for all citizens in the European Union, leaving no one behind. And again, on the affordability, I think that through research and innovation, we can contribute to this to make sure that cheaper solutions become available, and also linked to this human-centric approach to the energy transition is, of course, the behavioral changes that are also needed next to the technological developments that will help our energy transition. So I would like to stop here. I mean, obviously, there are many other issues here, but for me, the 4 key challenges that I want to mention today to you are the grid integration, the energy storage, the material question, and the human-centric energy transition. Thank you.
Thank you. You summarized it, I think. I was about to call upon Paula because you laid the track to the societal and human-centric approaches, but I also promised that if someone dances, and Jochen danced, Jochen.
Maybe I can somehow find a compromise between these two, because I also wanted to touch on the societal or the human centricity. Coming from another angle, Rosalinde said that talked about this scientific powerhouse. Yes, and I think we have also said at some time before, Europe is certainly world champion in the number of transition-related research and demonstration projects. Unfortunately, we are not at all world champion in demonstrating that we use what we have found out. So you could say we are very good in educating the people working in this domain, which is very important. We didn't talk about skilled resources yet, but this is another challenge. So it's a very helpful thing, but it's only part of the journey. And one thing we need to understand, and that also reconnects to my initial statement on we need to understand the system implications. And allow me to talk a little bit about grids now, connecting all the dots in the power systems. We have learned that we have to focus on developing grids in the sense of that we may need to build new lines. You could still argue distribution networks did not get the attention they desire yet, but at least on transmission, we have well-developed processes how to develop the system. However, we did never talk about, or not that much about that, we may not only need other lines, we also need a much more digitalized system and new functions of the grid to integrate all the distributed resources. So it's not only a structural shaping of the future grids, it's also a functional shaping of the future grids, and that needs to be rolled out in time. Here I come back to the deployment. It doesn't help if somewhere in the grid a nice demonstration project is built, future-oriented, and nowhere else, and users of the grid cannot rely on getting the functionalities they need to integrate. We are talking about a different system than we used to have in the past. And this is a technology game. And it needs to be shaped technologically. And this is deployment. And now I come back, I said, I want to build a bridge to the human factor as well. And we also, I think, getting support from the people, from humans, is not only about affordability. It's also about that they understand and something between at least tolerate, better accept the changes taking place in their environment. And in those regions of Europe where we are more advanced already with the transition and with the growth of distributed generation, we see people opposing against this massive rollout of technology standing in their environment. One thing that has, I think, not sufficiently discussed over the past decades is that distributed generation means much more visible technology, much more visible impact in the environment than what we were used to. And somehow people are not prepared to accept that. And we need to overcome that. Unfortunately, despite all the achievements of the past 20, 30 years, we are still in the first quarter of the journey and not close to the end. Yeah.
Jochen, you're rightly pointing to the grid stuff. But before we dig too deep into that with the societal discussion, I will come back to that. My first question would be, and it struck me when I read this new IEA report with the 80 million kilometers of lines that we have to build. And I do not even recall, Taeyong, if it was in Europe or in the world, but 80 million kilometers. Isn't that an issue with, I don't know what you would use, copper, aluminum, or what will you use to build these lines, Taeyong? Is there an idea?
Yes, this building this 80 million kilometers of transmission and distribution lines is a big challenge to allow this the robust transition in the context of a high the share of renewables in the system. So we released some major report on the role of grid networks just a couple of weeks ago, and I was not part of the team, but I was involved I was thinking from the material point of view about that aspect, because these lines require a lot of copper and aluminum to build. And so in terms of copper, and when we calculate the amount of materials to support that, the line additions and also compare that with the expected supply from today's announced project, and we see some gap between expected supply and what is required in our natural scenario. So around 15 to 20%. And then we are raising questions about how we can close that gap. So one way is absolutely increasing more investment in copper supply and to develop new projects, but that alone may not be sufficient. So we need to have some another solutions to close that gap through more innovation such as digital or localization of the grid networks, and also some, for example, if we adopt more DC system than AC system, and that requires less materials to build. And also if we adopt more aluminum in the lower voltage segment and also even the medium voltage segment, and that also can reduce demand for copper. And those kind of some solutions is also quite required. And also much more the role of the scrap recycling in this picture, because if you think about the copper, and demand for copper has surged in early 2000, and when China and other emerging developing economies was economies developing, and that at some point those materials will come into the pool of the scrap materials, and then how we can better collect, and those things is quite important to address this.
So we have an idea. We have an idea how to replace one material with the other. I mean, do we also get to completely new solutions? I mean, we have heard about windmills without blades, vanilla instead of vanadium. We have heard about calories in galleries. What prevents us from developing completely new alternatives? I mean, I'm not against building grids, get me right, but in this little film we said, maybe we need not transport so much electricity if we produce the electricity where we need it. So this distributed way of doing it, as Jochen described it. Can someone comment on that? Why don't we go completely new directions? Is that Luigi?
Yes, maybe to add a small contribution to this, I think today we are using 7 parts out of 10 in the energy consumption made by molecules. So it will be really difficult to bring this contribution of molecules to zero. And we need for the transition clean, sustainable molecules. So just to make an example of what's ongoing at the European level, there's a design of a European hydrogen backbone, which is a transmission grid to transport hydrogen all over Europe, particularly to link production sites where hydrogen could be produced at low costs with the consumption sites, particularly the biggest industrial districts in Europe, in Germany, in the north of Italy, in France, or in the Netherlands. This has even some assets at the ground, so moving molecules in large amounts of energy is costing 10 times less than moving electrons at the available today technologies. Of course, maybe in the future there could be a progress of different sectors, but I think we should look with an holistic view on how to complement and strengthen one sector with another. Of course, as said even before, with the tentative to outreach a common goal at the end.
But who prevents us from that? Is it at the end people or money or policy, Jochen?
May I, first of all, because you referred to me having talked about distributed generation, and you somehow concluded from that this is local production. Partly, yes, but one of the challenges that we have to accept with using renewable energies, particularly wind and solar, is that we have to harvest them when and where they are available. And we have seen that, well, look at Europe, one of the biggest pillars of European electricity strategy is offshore wind, and that's definitely not local. So we need to transmit, we need to bring energy to the places where it's needed. And indeed, we have alternatives for that. We can do it by electrons. We can transform the electrons into molecules and transport them. And we need to understand this as an integrated system and find the most efficient solution. I think that's one important element, because well, there will be a lot of scarcities in this system, and therefore efficiency plays such an important role. By the way, it's also linked to the question of storage, or I would prefer to call it long-term flexibility, because molecules can help a lot here. And at the same time also solve part of the transmission problem.
We need
On
to
the other
discuss
side, there is, I'd like to talk
Yeah.
a little bit about possible areas of innovation that could help us reduce the material that we need. If you look at one important component in a power system consuming reasonable amounts of material are transformers. If you would go to higher frequency transformers, which is possible technically, and we see such developments, and connect them to the existing grid with the existing frequencies through power electronics, then you can build the transformers significantly smaller. It's not only a few percent, it's factors, which saves a lot of material. And if you talk about the lines, although it has always been a promise for the future, sort of a silver line at the horizon, unfortunately, horizon continued to be quite far away. Superconductivity. If we have a breakthrough in superconductivity, this means orders of magnitude more current through the same material, the same amount of material. Of course, not the same material, but the same amount of material. So there are technological opportunities which needs to be explored, and they are not for granted. Success is not for granted, but we need to continue searching and exploring.
Thank you, Jochen. I have seen two fingers, but first I must ask this question. Yesterday in the newspaper, Luigi, I read, we are ready to build this giga pipeline for the hydrogen from Portugal through Spain and France to Germany. I mean, we transport electrons or molecules, or can we replace electricity grids with hydrogen pipes?
No, I think there's a complementary roles in between the two kind typologies of grids. Even because hydrogen, we represent its role as a partial role in the transition. All the different scenarios are giving a role to hydrogen being in between 15 to 20, 25 max percent as final energy consumptions at 2050, so at zero carbon. So this is for sure a complementary role, but it is important because we can move large amounts of energy. The cost of this being small in some countries in Europe and maybe even abroad, and we can use existing grids as well. Just a number is that 70% of the gas grid of Italy today utilized for natural gas, it's hydrogen ready. So we have a saving in investments even through this aspect. And last but not least, if we couple the hydrogen grid infrastructure with depleted gas basins underground, so we are demonstrating this feasibility inside several projects in the Clean Hydrogen Partnership to store hydrogen in depleted gas basins. We have a major seasonal reserve for Europe, and this is one important aspect to be considered.
So combining transport and storage. Philippe, I have seen your finger. Whatever you want to say, but you also tell me how you get all the material in place that we need for the hydrogen pipes, because they are also covered by material. I have seen the hand of Paula as well, and while we are trying to get the voice of Philippe, Paula, are you ready to speak?
I think there's been a lot of interesting questions here, but I think we're also talking at the same time about sort of two different things related to research and development and scale up. Because on the one hand, we need to sort of scale up the technologies that are applicable now so that we rapidly reduce fossil fuel consumption and the gas dependency of Europe. And on the other hand, we need to do the research and technology development that we've heard about, which is potentially scalable in 10 or 20 or 30 years' time. And I think these are kind of slightly different topics and we addressed with this, but I wanted to react to the earlier topic about practices and behavior, in a sense that I think, well, we both have the limit of technological development taking place, but also I think it's what we've noticed in the field of sustainability transitions research, that actually the changing practices can be much more difficult than changing technology, and like getting acceptance of people to use technologies that change their existing ways of working. And I think it applies both to professional but also everyday practices. And I think regarding professional activities, we need to somehow create new exciting careers in the area of clean energy. And I think I've seen examples of offshore wind power engineering, but also it's sort of still they're competing for skilled labor with offshore oil and gas, for instance. But the citizen perspective, I think, is also important, because although the price and availability of new solutions have gone down, solar panels, different energy efficiency solutions, they're still not accessible for the people with lower incomes. And this makes them unavailable to many people and increases inequality. And I think, therefore, we need to kind of couple new types of business models that make these technologies accessible to more people. And also, I think in building, there was one talk about building-related energy solutions, and there the issue of accessing reliable contractors has been a particular issue for many end consumers. And I think one way to support this is thinking who could be like the trusted intermediary actors for people to find contractors. And then, of course, there's the political side. There's still a lot of strong pushback for the energy transition that seems to be often stronger in the politics than even in the companies operating in the energy sector.
When I listen to you, do we have Philippe back? Can you talk, Philippe?
I hope so.
Yeah. So please,
okay.
You had your finger up, and then I would like to ask a question to Paula again.
Yeah, so a lot was said already of what I wanted to highlight. I think that, just to come back to your question, why are we not developing the alternative solutions? I think we are, but yeah. It's not a simple. There is not just one simple magic solution. And this was emphasized already by the other speakers. I think that we need to have this holistic approach, and we need to develop in parallel all these complementary solution that really will contribute to the main goal. So if we just think about batteries, I think we were able to reduce the cost and to improve the performances of batteries over the last 10 years by roughly a factor of 2. And this is not the end of the story. We are still continuing developing new generations with the solid state battery that should reach the market in the coming years. And if you look at wind, just looking at the size of the windmills over the last 10 years, it's amazing to see how we were able to improve also the performances of this one. Also addressing issues like sustainability by developing really the solution, the composites that really make the blades recyclable. We are also working on the recycling of permanent magnets and all these other issues that have to be taken also into consideration. So this is ongoing. I think the issue we are facing is that's a huge need for this alternative solution in such a short timeline that is really also part of the difficulty
Correct.
that we need to address.
Thank you, Philip. Thank you for pointing to this question of speed. And yes, Rosalinda, I mean, we need to be faster. Everybody would agree we need to be faster sometime, and we cannot do everything at the same time. So we need to make choices, probably. Are there, say, mission critical issues, mission critical approaches, methodologies, funding programs, or whatsoever, Rosalinde, that we should concentrate on to get the right speed?
Yes, thank you, Ludwig. And I think this is a nice segue also to respond a bit to what previous speakers mentioned. We have in Horizon Europe, our European program, a new instrument which we call Horizon Europe Missions. And I think we can learn a bit from these missions and the approach that we have taken in these missions also to accelerate the clean energy transition and address some of the issues we have been discussing. So first of all, these Horizon Europe missions, even though they are rooted in the European Framework Programme for Research and Innovation, they want to work across silos, across programs, and they want to accelerate moving from research and development to deployment, scaling up. So basically, we also need the buy-in from other European programs that focus more on deployment and not on research and innovation. And this links to what Paula said, and I think this is so important, that of course we have a double challenge here. On the one hand, we need, of course, to continue to invest in new research and innovation to address current challenges. But as Paula rightly pointed out, the solutions that we are working on are really the solutions then for tomorrow. So this is longer term. But at the same time, we need to scale up and deploy the technological solutions that are available today. And there, I think we have, at least in the European Commission, a huge challenge. I mean, we have invested in large-scale demonstration projects in previous framework programs on research and innovation, in previous partnerships that we have had with industry. And I think there it would be really good if we would also focus a bit more to see, you know, what can we do to really move from the large-scale demonstration to scaling up in deployment. And I also hope that the Clean Energy Transition Partnership can help us a bit there. The second thing I wanted to briefly mention with this mission approach, one other principle apart from this silo breaking and moving from research and development to scaling up and deployment is that we are working directly with citizens. To give you a concrete example, we have a cities mission where we are working with 100 cities that develop plans to become climate neutral already by 2030. But one of the requirements is that these action plans that cities are working on are co-created with the local communities. And here we come really with this, you know, acceptance, the societal acceptance and the buy-in from the citizens. So if you, from the starting point, involve the citizens, ask their opinion, you know, on potential solutions to scale up the transition, we believe this will be very beneficial also for this dimension of the human-centric approach to the transition, namely not only affordability, but also the buy-in. And maybe one last sentence on, you know, the political buy-in as well. That's also something that Paula raised, which I think, again, is very important, in particular in the European Union, as next year we will be facing a new European Parliament, a new European Commission. And there, I think it will be very important for all of us to keep saying that our sustainability is not only about saving the planet, it's also, and it should be also good for the competitiveness of our European industry. So basically sustainability and competitiveness should be two sides of the same coin. Thank you.
Thank you. I have seen Jochen dancing, but Jochen, please be short because I have to give the word to Paula. She has to leave at 12:30. So you will have a last say, Paula. But Jochen.
Okay.
Industry.
Just one question on what can us help with deployment. I think one thing that we have seen and also addressed, we in that case means indeed the T&D Europe had, so our industry is, a lot of the solutions are that have been developed, demonstrated, are depending on the grids or are even addressing the grids. And grids are a politically defined infrastructure. More precisely, they are regulated monopolies, and network operators only do what regulation allows them. And our traditional regulation system is about ensuring that the grids are fulfilling their traditional task, not any new tasks, the traditional task as efficient as possible. That needs to be changed. The task needs to be, of course, still to do it as efficient as possible, but also to be prepared for the future tasks and make sure that necessary things are available in time. And that brings me to the point, regulation has rarely ever been part of the research work, but regulation needs to transform the research results into the deployment in the grids. So this is, and regulation again is also not here on the table.
Yeah. To be honest, by purpose. Because
but shying away from uncomfortable things doesn't solve problems.
No. We are not shy. We are not shy. The question is, and we are the CETPartnership. We are in research and innovation, and of course the regulation and policy are also depending on the outcomes of research and innovation.
But allow me, there is also research on regulation. This is a discipline in itself.
So what you say, that is important. So Then we are also in political research, probably political regulation and so on. But let us stick a bit to this human-centric thing, because I really have to give Paula a chance. She has to leave in 5 minutes. What is your final advice, or maybe a wish to the CETPartnership? What would you like us to do? Can you please help us?
Oh, that's a very challenging question. But I first of all, I wanted to say that I actually see what I've done before in my research, and I've noted the importance of intermediary actors and organizations in change and transition processes. And I think the CETPartnership seems to be like a good example of the type of intermediary actors we need to push forward the energy transition. I think, and I'm not quite sure what type of research portfolio you are engaged in, but I think the discussions today have really highlighted, again, the connections between the social and the technical. So I guess also having in the future sort of projects that look at not only the technological perspectives, but also, like Rosalinde pointed out very well, like citizen involvement, also user involvement, and sort of looking at kind of the barriers and opportunities to also advance the application of the new solutions in practice, and what might be the issues to overcome. So I guess that would be sort of my advice, expanding a little bit of the research focus, and perhaps also including the role of policies and regulations, perhaps like Jochen noted, but as part of the sort of technical search for solutions.
Thank you for that, and thank you for coming, Paula. You are in a hurry, I know. You will leave us now, and I'm asking you to shake hands with Michael Hübner, whom you will meet in the door. He will come on the panel. I was watching also the chat. There was not so many questions. One I introduced to you, and the others maybe will come. But let's do a quick poll, a quick question, a last question to our audience. Can you show that, please? Yeah. We said, okay, we know a lot. We also know that we don't know things. But when it comes to who is the most responsible party that could bring more resilience to the supply chain, when this is the big headline, and we have been giving you, wait a second, please. I have to switch to the next slide, probably somehow, and I don't know how. Here we go. Sorry. You can vote. We give you the choice: political governance on EU and national level, or transnational research and innovation programs like the CETPartnership, for example, or I don't know, Interact programs, globally acting international enterprises, local regional development networks. Is it the financial institutes that will at the end bring more resilience? Who is it? It's multiple choice. You can, but please don't put 6 X's, while we know everybody has to contribute. Make a choice of maybe 3. I'm not going to control it. Let's wait a bit, but we can go on while you vote. We show the results later. We are turning into a last round for everybody. Please, same question to you. CETPartnership is powerful. We have money, we have bright people, we have an organization. What would you expect CETPartnership? What would you advise? What would you wish? So more or less, it's a last say from everybody until Michael Hübner will join us. But I think he can listen. I know he always has this microphone. And who can start? What do you wish? What do you advise to the CETPartnership? If no one wants to take the step, I assign it to Luigi.
Thank you, Ludwig. Yeah, small advice. It's maybe even highlighting what we are doing at Fondazione Bruno Kessler, but even the model that we are implementing inside Hydrogen Europe Research. So research is not made only by researchers. We are researchers, technologies, innovators. Some of us are pushing, some other are working with a pull approach. And we should emphasize these different roles we have as researchers, as innovators, even to look to a novel collaboration scheme between the industrial sector and the research. I think that joining our forces, particularly even in technology infrastructures that are at the relevant scale, we could speed up the development and even deployment of the solutions. This is what we are doing here in Trento. So developing a facility of a relevant industrial scale where we are working in co-design, co-development in joint innovation labs together with industrial players. And this is even reflected in what we are moving forward in Hydrogen Europe Research. So with 2 new working groups, one of these looking to the next generation technologies, so priorities for the low TRL research, but on the other side, even supporting the industrial sector in improving the existing technologies in a faster time. This model is reducing, we have some track records, 30-50% the development time. At the same, we need even new skills, wider number of skills in Europe, which is a potential bottleneck to the development of the different sectors in the energy transition. And these skills are not only higher education, for example, doctoral program, but even technicians, even reskilling and upskilling of the workforce to support the transition to new sectors on renewables, on the different clean energies, and this is of much importance, I would say.
Thank you. I take the opportunity. I have heard that my friend Michael is in the room. Can you join us on stage? Hey, shall I
Hello,
call you
everyone.
Mick?
Can you hear me?
Mike, whomsoever, our valued coordinator of the CETPartnership. I asked you to come on stage directly. I don't know if you have listened to Luigi. I
Yes,
will
of
ask
course.
you also, Michael, what your impression is from what we have heard, but what Luigi said, linking research to innovation to companies, to the field. I mean, how does that sound to you? Isn't that the final idea of the CETPartnership?
Yes, I mean, what we have to be focused on is impact in everything that we are doing. That's in our books from the very first moment. And I think we tried really to set up the initiative in a way that we can help with that particularly. Impact can only be reached if we link the dots. So the innovation, we always talk about research, technological development, and innovation. And I think the innovation part, which to me means transition per se, has to be the strongest part, I think.
Okay, I think here Rosalinda would agree, right? Our partner on the EU level.
No, absolutely, absolutely, and I'm very happy to hear indeed the link being made, between researchers and the industry, because I think we can no longer continue to work in silos. We really need to work together to make sure that also we listen to the needs of the industry for more research and innovation topics, and at the same time also making sure that the research results is being used by the industry. Now, I wanted also to refer, I'm sure you're all aware, but we are very happy that the Commission has adopted on Friday a revised SET plan, which is a different SET because it's with an S. It's the Strategic Energy Technology Plan. And of course, the SET partnership with the C, the Clean Energy Transition Partnership, plays a crucial role to deliver also on our revamped SET plan, so the Strategic Energy Technology Plan, which is really a big political priority for the Commission. Since here we are working as Commission together with member states, but also with researchers, academia, and the industry. So it's really a place where everybody comes together, and there I believe that also the partnership can make a huge contribution, in particular to the more horizontal strategic work streams that we have proposed for the SET plan to work on, which are also linked to skills development, materials, citizens engagement, circularity, digitalization, etc. But I think the partnership will continue to play a very important role, not only to develop new research results, but also to support the finalized research result to find its way to the market. And there, I think it will be very important to collaborate with industry, but also with the member states. Because in the end, we also need to make sure that we have the buy-in from the member states to make sure that we can really start scaling up and deploying the solutions that we have developed. And maybe lastly, I wanted to quickly mention also the important role that the partnership plays in the context of mission innovation, which is an international collaboration to accelerate clean energy transitions globally. And I also think it's really great that already some third countries have shown interest to join the partnership with a bag of money. So that is really great, so that we can also reap the benefits of collaborating across the borders of the EU. Thank you.
So we go beyond the EU, Rosalinde. That brings me to a question that I have seen from the audience. I don't know if you can answer it, or maybe Luigi. It's about hydrogen. The question is from Gerdi Brembrock, one of our leaders of one of our transition initiatives. And she asks, what does the panel think about the dependency from hydrogen from equatorial countries, so beyond Europe, that may well develop in future winter months in terms of security of supply? How is our relation? It's getting a bit political, I think, here, which we wanted to avoid, but I think we have to discuss that. Rosalinde?
Maybe I can start, and then Luigi, who is very knowledgeable on hydrogen, of course, can maybe complement me. No, I just wanted to point out that from the political point of view, in the Repower EU plan, we have committed ourselves as European Union to not only have sustainable energy, but also to make sure that we reduce our energy dependencies. So as part of this Repower plan, when it comes to hydrogen, we have set ourselves the objectives for the European Union to produce an additional 10 million tons of hydrogen inside the European Union by 2030, and then also to import the same amount, so 10 million tons into the European Union. So it's really here that the Repower plan, on the one hand, we want, of course, to strengthen our domestic production inside the European Union, but at the same time, we need to continue to collaborate and import into the European Union. But also there, we need to make sure that we do not fall in similar situations where we have really a dependency just on one country or a group of countries. So I think the ambition is there. So that's also why we are investing heavily through the Clean Hydrogen Partnership that we have with the industry into also fostering the increase of the local, if you want to call it, production of hydrogen inside the European Union. But I'm sure Luigi has some things to add.
Sorry if I interrupt you. Is that a question, Luigi, is that a question of investment or policy or goodwill, or is it still a question of research, maybe political research? How we deal with that international situation in energy, especially hydrogen?
Just to complement what said by Rosalinde, I think overall Europe should have a long-term geopolitical view on the international collaborations. This for multiple reasons, to secure the materials for the products of the future that our industry should produce. But even in the Clean Hydrogen Partnership, we are looking to have a solid relationship with North African countries, particularly Tunisia and Algeria, where infrastructures are under construction to import hydrogen from there. Of course, we need to produce hydrogen in Europe, but even differentiate the import in between different countries. And the 10 million tons of hydrogen that is looking to be imported in Europe from the REPowerEU plan, 4 million are in form of ammonia. So importing hydrogen from long distances, for example, in collaboration with Chile or with other countries. So the differentiation could be a way even to reduce the political criticalness on some countries that could have issues in the next future. On the other side, I think we should create bridges more than having political conflict.
Luigi, let's create a bridge between the hydrogen partnership and the clean energy transition partnership. What is our bridge? What could we do together, achieve together?
I think there's multiple ways of collaboration, and I will be more than happy to create a bridge here. I think hydrogen is even part of the clean energy transition because, as said even before, we are not working on silos. We are trying to contribute each one to the final goal of the energy transition. So I feel myself inside the Clean Energy Transition Partnership under this point of view.
You are a friend. So we are coming to the end, ladies and gentlemen. We have 2 or 3 people who should have a last say. I have Theon and I have Philipp and I have Jochen, and maybe then Rosalinde can talk a bit to Michael Hübner while I go lunch.
Maybe I can just quickly respond to what Luigi said about this energy geopolitics and then also to some final word. So on the energy geopolitics, I think even in the transition scenario, the concerns about the geopolitics doesn't disappear. So in the past, it was about the Middle East, Russia, and OPEC countries. But in the transition, it become more broadened. The battlefield is become on hydrogen. There are concerns about relationship between consumers and hydrogen exporters, and also critical minerals. Then you have a range of the very concentrated supply chain in few number of countries. So in the critical minerals, especially concerns about refining and processing value chain where we have a very high level concentration. So, but what we are seeing is there is a big ambition to diversify sources of supply in the advanced economy in Europe, and also the developing economies want to expand their value chain beyond mining. So in Africa and Latin America, they want to go beyond mining to expand the value chain, adding the value chain in the processing, refining, and component segment. But what is happening in the marketplace is about most of today's plant refining processing plant is being planned in today's dominant players. So connecting these studies really critical through some strategic partnership between consumers and emerging producers and make investment happens. That is
and you wish, Theon, you wish or advice to the CETPartnership?
So
we invite you for the next panel?
Yeah. So just now changing the topic to the CETPartnership of expectation. I think I will just touch upon maybe there's a scope the IEA and CETPartnership can work together, because when we make projection about material demand in the future in transition scenarios, and we have a base case, but we also develop some range of alternative technology cases where we assess quantified impact of different technological evolution in material demand. So we released in the Data Explorer tool in the IEA website, where users can easily navigate and access the impact of this technology. For example, and in sodium ion, we have some uptake of sodium ion batteries in the marketplace. So if that technology take a much higher market share than our general base case expectations, and if aluminum takes much more market share in grid cables, and if the battery size just keep increasing until now, but if they can be moderated, what could the impact of these technology options on material demand? So we have this tool, but what we need is some input about what kind of new technology opportunities exist. That partnership, I think, can identify those range of the new technology options, then maybe IEA can feed that into their modeling framework to assess the impact, and then circle back, and then partnership can promote that to the industry to accelerate progress on technology innovations. That is the kind of virtual cycle
Thank
I
you.
can see. Yep.
Thank you for joining us, Theon. Philip, there is soon Christmas. You have a wish free. Emiri has a wish free to CETPartnership.
Yeah, well, we first have a wish toward the member state and the commission that was to bring the partnership proposal on advanced materials to become a reality. And really, we are convinced that this proposal, for which is currently named Innovative Materials for Europe, which is really willing to address all the different and bring together all the different stakeholders which are interested into advanced materials, from those who are designing these materials to those who are integrating them into the different technologies for whatever strategic market, and also to those at the end who will have to recycle these materials. The wish is really that this partnership will be a co-program partnership with industry. I just want to re-emphasize really the comment that was mentioned by Rosalinda, that every challenge also brings opportunities. And I think that we have here a big opportunity to reinforce the competitiveness of European industry in the fields of advanced materials. It's also about the resilience of Europe, that we need to relocalize in Europe industrial activities on downstream the critical raw materials. We have not really touched these aspects in our panel, but it's not enough just to secure again really the sourcing of critical raw materials. We need also to make sure that we will be able in Europe to transform these raw materials into advanced materials which are needed in the different technologies. So that's key. And coming to your point regarding the Clean Energy Transition Partnership, I would also like to invite you to further discuss on what are the possible synergies, both with the battery partnership. So Bat4EU, you know that I'm acting as the Secretary General of this one, and I think that we should explore what are really the different areas for collaboration between our two partnerships. And of course also when the new partnership, or even before the new partnership of advanced material will be in place, I would really very much welcome some discussions with you to identify also the areas for collaboration and for synergies.
Thank you very much. Before I give the last word to Jochen, can we please see the last poll? I see something that you don't see. Can we make it a bit larger even? So what do we need most? We need political governance. We need local and regional development networks. We need transnational research and innovation programs. Also global acting companies, international collaboration networks. No money. That's a bit doubtable, but we need governance and we need research. Thank you for that one. Would you agree on that, Jochen?
Well, I don't see everything. Let me begin with your surprise, no money. I would agree with, not with saying no money, of course, but agree with that it's more a question of governance, of being prepared, of ensuring access, and of course, following that also money. But money alone will not solve the problem. It's a means for a second step. But I guess I'm also asked about my advice to a CET partnership and as a CET partnership, sorry, and well, I guess it will not be a surprise. I say I believe we have there have been many aspects of partnership being mentioned, and being representative of industry, I would also like to highlight we have always felt being part of partnering, and this is very important, and we are also committed. My wish would be to expand it to less technical topics like regulation, which is not political, it's macroeconomic science first, and of course defining and implementing is a political question, but the part we need to look at is more the scientific part. More make that an integral part of the holistic. It has always been seen we need to have a holistic view. Yes, but holistic does not only mean look at electricity and hydrogen and other parts of the energy system. It may also mean look at other disciplines. And the same applies to social sciences. I'm currently engaged in a German big research project funded by the German Ministry of Science. And there, one of the most interesting and insightful elements is that we had managed to get a real intensive collaboration and exchange with NGO representatives of the civil society, working with people, trying to make them understand what the energy transition means. And I believe this is the area where participants have really learned most. It was not an easy way. Interdisciplinary work is never easy. So it cost some pain in the beginning, but then it became very fruitful. So I think this is another dimension that requires even more attention.
Thank you, Jochen. Thank you, Theon. Thank you, Luigi. Thank you, Philipp. Thank you, Rosalinde, for joining us, sharing your ideas, proposals. I hope we can invite you again when we do the next annual conference a year from now. For the time being, you are released. You can go home for lunch. Rosalinde can take care of the 3 kids or the other business you have. I would like to stay a while with Michael Hübner to digest what we have heard. Thanks for coming, Michael. So, we have 4 minutes to assess what we have heard today. What have you heard?
Yeah, first of all, I want to say thank you to all these highly valuable inputs, and for taking your time, for all the speakers and panelists to take your time to share your insights with us. I think it was really a broad view of topics, a broad variety of topics, and many of the inputs reminded me at a book that I was reading when I was a teenager, and I was going to my bookshelf and I found it. So that was the analysis of the Club of Rome at that time. And I mean, it brings us a little bit in a direction that I originally didn't really want with this conference, with this policy conference, but I think it's important to spend 1 minute on this. I think it shows that we need a holistic view, and we need a holistic approach to the energy transition and to our global transition at all. If we just consider it to be the next industrial revolution based on new technologies, that's way not enough. The next industrial revolution and the energy transition has to become an efficiency revolution in a very broad sense. Otherwise, we see very clearly, and I think many of the inputs from today showed that very, very obviously, we will run into global problems. So that's the big challenge, and it also means that if we need a broad or a holistic approach, I would very much want to underpin the voices that have been saying today that we don't only need technology research. So it's not only technique as such, it's always technology in the context of society, in the context of culture that we are developing. Therefore, we need research and innovation. Again, I want to underpin the innovation part on different layers. So it's not only the technology itself, it's also how do we organize the whole system? How do we formulate regulation, but also the market framework? How do we organize the interplay of the different players in this new complex energy system? And the third layer, the transition. How do we really co-create in society these solutions. And here I want to make the sidestep again to what Paula called the positive security. We are able to make choices, and particularly on the local and regional level, we still have the possibility to connect to our limits, to connect to a feeling, to a gut feeling of where our natural resource limits. Because in this global world, and this is what brings us to the topic of today, the global value chains, makes us feel that everything comes, anytime, to what amount ever we want. And to look deeper into this global value chain topic, I think shows that also here we have limits and we have to deal with these limits. But basically, the message of today for me, because what I said before is it's easy to get lost in this complex world and this huge challenge that we have to face. We need also to focus, and I think the message of today, to me at least, should be, when we look into this topic of the global value chains, that this is also an economic opportunity for Europe. We are, on the one hand side, it can easily become a showstopper for our energy transition in Europe if we don't get the materials, if we don't get the components, if we don't get all the things we need in time. On the other hand side, it shows we also need a next generation of technology. We need a next generation of production technologies. Because if we as Europe want to be a player on the global scene, also in terms of producing these energy technologies, we need to find a way how to be competitive. And this could be in an approach to be more efficient. And this brings us into many topics like recycling, circular economy, and so forth. How can we find ways to make these technologies available, or these services, to go with Professor Braungart again? It's not only to sell technology, but it's really to provide the service in the most efficient way, because that makes us also competitive. And the last sentence that I want to convey is, and I think that's so an important and inspiring outcome, I think, for us as the Clean Energy Transition Partnership community. We in the Clean Energy Transition Partnership are unique in a sense in the set plan, because we are not specialized on one of the technologies. That, of course, makes that we maybe cannot look into the depth of any of the technologies, but we have the big chance to bring these different parts together. We have the 7 transition initiatives that are looking on different aspects of the energy transition, and we have the opportunity to bring things together. And we are a global network, and this makes it possible that companies that want to find their way into these global value chains with their technology, which maybe they didn't even think about, that this could be a technology that plays a role in the energy sector. Maybe you have an interesting material. So please use this network to find your way and to develop your company into the value chains of the energy transition. That's really a great opportunity. I think that research, technology development, and innovation as such is offering, and that the Clean Energy Transition Partnership as a network particularly is offering to you.
Michael, Mike, thank you for these summaries. And it all starts in this afternoon with some more opportunities to meet people, to discuss and exchange. I call my colleague Julia Chenu. You are responsible for the rest of the conference. You show us what's next. I say goodbye.
Yes, hello everyone. I'm Julia Chenu from the Coordination Secretariat of the CETPartnership. So yes, this afternoon we will already start putting what the rich input we had this morning into action and co-creation. So I invite you to join our sessions on the knowledge community, which is a place where we do co-creation on such topics as societal acceptance, social topics and regulations, as were mentioned this morning. So if you want to continue the discussion on this, this is part of the knowledge community, and also the importance of bringing the innovations to the market was also highlighted this morning. And this is also what we really want to do with our other special feature of the CET partnership, which is the impact network. And so both will be presented and worked with this activity. So we have, you have the chance to have a presentation and also work this afternoon on this. But the conference continues tomorrow. Tomorrow morning, we will have a deep dive in our challenges and topics. And you will learn more about our seven main thematic challenges of the CET partnership and of the projects that have already been approved in our first call for project proposals. They are just starting, but many of them will be presented tomorrow. So I invite you also to join that to know a bit more about the challenges and the new projects. And at the moment, our second call for project proposals is running. And so this is now also the time to ask tomorrow afternoon your last questions and get more tips before the deadline for the submission of the pre-proposals in the 22nd of November. So I invite you to join that session tomorrow. And after that, and also during the rest of the conference, so starting also this afternoon, you can anytime use the platform, this event platform on B2Match that you are in at the moment, to do some matchmaking, find partners, and find partners to build new projects. And we will be really happy if we get also some new applications in this current call for project proposals. So don't hesitate. And if you have any questions about the matchmaking or anything, you can also contact us anytime on the platform. Thank you.
Thank you very much. From my side, nothing else to say, but a big thank you to Christian Spanek and his team, who are always in the back, always appreciated, helped us through this big, massive first 3 hours of the conference. Thank you for joining us. The last word is with our coordinator, Michael.
From my side, I want to say also a big thank you, not only to the speakers from today, like I did already, but also to the whole team, Ludwig, Julia, and the whole team that put these interesting contributions together. I think it inspires us for thinking about the next activities of the partnership. And to the audience, thank you for your time. Thanks for joining, and please use this network that we are providing for you. Thank you.
It's a challenge. It's our challenge. It's your challenge. The further development of technologies and concepts for the energy transition. Because we need more than what we already know for our clean energy future. An energy future that really offers perspectives for all inhabitants of this globe, our economy today and our grandchildren tomorrow. Yes, it is evident. We need technologies to convert, to store, and to transport energy. We need control and smart systems. To provide these technologies, we need materials, knowledge, skilled people, and production lines. However, we also need partnership, international collaboration, shared efforts, and skills. But what is new about this? It is the new questions that arise from the exponentially growing global market uptake of the new solutions. Where does this all come from? Can we be sure to have all the materials available? Will we get the components and technologies For the growing number of devices in time, are we able to have our share in the production of technologies and in the value chains of the new evolving markets for new solutions and systems? Things have changed since it all began. So now we have to face up to these changes. A high share of components comes from a very low number of producers. We get more and more dependent on a number of special and highly scarce materials. Not only during the pandemic, we have experienced the meaning of vulnerable supply chains in a globalized world. So why not doing research on how to produce batteries that use dramatically less, or at least less rare materials? Why not considering recycling of components and materials to develop super efficient production lines for a new generation of PV panels, and in that way be at the forefront of producers again? No, of course. These are all not yet answers. These are only questions. Out-of-the-box thinking is required, and it is a tremendous opportunity to do it together with partners around the world. It sounds too complicated somehow? Too impossible? Honestly, that's what people also thought when the first developers considered bringing energy to Earth from the space. Thinking that way means to do research and to develop technology for the future. This is what energy innovation is all about. Working on such kind of solutions is paving the way for the next phase of the energy transition. It is a challenge. It is our challenge. It is your challenge.